10, 9, ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and liftoff.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
Italien steht nach der Parlamentswahl möglicherweise vor einer schwierigen Regierungsbildung. 5 Stunden nach Schließung der Wahllokale zeichnet sich nach Hochrechnungen ein enges Rennen der großen politischen Lage ab, zumindest im Senat. Aber auch im Abgeordnetenhaus liegen das Mitte-Links-Bündnis von Spitzenkandidat Bersani und die Mitte-Rechts-Allianz von Ex-Ministerpräsident Berlusconi derzeit knapp beieinander. Die Abstimmung gilt als Richtungswahl für den Reformkurs des Landes.
Das Öffnen der Wahlurnen heute der Start zu einem Wechselbad der Gefühle für die Italiener. Nachmittags um 15 Uhr verkündet der staatliche Fernsehsender Rai einen Sieg von Mitte-Links und das in beiden Kammern. Demnach würde der Chef des sozialdemokratischen Partito Democratico, Pierluigi Bersani, über eine stabile Mehrheit in beiden Häusern verfügen. Das italienische Parlament besteht aus 2 Kammern, dem Abgeordnetenhaus mit 630 Mitgliedern und dem Senat mit 315 Sitzen. Eine stabile Regierung bräuchte eine sichere Mehrheit in jeder der beiden Kammern. Am frühen Abend dann Spannung und vorsichtige Hoffnung im Lager von Silvio Berlusconi. Zwar bleibt Mitte-Links im Parlament vorn, aber im Senat könnte Berlusconi die Mehrheit erreichen. Das würde ein Patt bedeuten, Unregierbarkeit. Das Wahlergebnis zeigt, die strenge europatreue Politik, die in die Rezession geführt hat, hat bei dieser Wahl eine Niederlage erlitten. Die Fortsetzung des Konsolidierungskurses mehr als fraglich. Ich vertraue niemandem mehr, denn Italien bricht zusammen. Berlusconi Nummer 2, wirklich? Nicht nur in Bersanis Lager beginnt sofort die Debatte um vorgezogene Neuwahlen. Mitte-Links könnte eine Regierung bilden, ein neues Wahlgesetz verabschieden. Und dann müssten wir, wenn es so bleibt, für eine stabile Regierung sofort Neuwahlen ausrufen. Des unsicheren Wahlausganges wegen hat sich bisher noch keiner der Hauptdarsteller vor eine Kamera oder ein Mikrofon gewagt.
Zu den jüngsten Hochrechnungen der Parlamentswahl in Italien jetzt live aus Rom mein Kollege Peter Dahlheimer.
Auch die neuesten Hochrechnungen ergeben kein anderes Bild. Italien stellt Europa und den Rest der Welt wieder einmal auf eine harte Probe. Zur Stunde hat im Abgeordnetenhaus Pierluigi Bersani mit seinem reformwilligen und europafreundlichen Mitte-Links-Bündnis die Mehrheit. Den Senat dagegen scheint Silvio Berlusconi für sich zu gewinnen. Der seit Monaten gegen das so wörtlich von Deutschland dominierte Europa hetzt und gegen die von Mario Monti durchgesetzten Sparmaßnahmen. Vielleicht können sich Bersani und Monti zusammenschließen zu einem Bündnis, um Montis Reformkurs fortzusetzen. Danach sieht es zur Stunde aber nicht aus. Am wahrscheinlichsten erscheinen derzeit Neuwahlen, und zwar baldige Neuwahlen. Das bedeutet, die harte Probe für Italien, für Europa und für den Euro hält weiterhin an. Und damit zurück zu Judith Rakers.
Der Wunsch der Türkei nach einem EU-Beitritt hat heute den Besuch von Kanzlerin Merkel in Ankara bestimmt. Ministerpräsident Erdogan forderte ausdrücklich die Unterstützung Deutschlands ein, mit Blick auf die ohnehin engen wirtschaftlichen Verflechtungen. Merkel sprach sich zwar dafür aus, die Verhandlungen über den türkischen EU-Beitritt wieder in Gang zu bringen, bekräftigte aber auch ihre Skepsis in dieser Frage.
Die Kanzlerin als Touristin, selten, dass sie sich für so etwas bei einem Staatsbesuch Zeit nimmt. Aber es lohnt sich, Ausblicke auf die einzigartige Landschaft Kappadokiens und Einblicke in frühchristliche Kirchen in Güreme. Tief im Inneren dieser Höhlen sind Fresken über Jahrhunderte erhalten geblieben. Weniger entspannt dann das Programm in Ankara. Trotz der guten deutsch-türkischen Beziehungen gibt es Konflikte, allen voran der EU-Beitritt. Da sollen die Verhandlungen jetzt zügig wieder aufgenommen werden, aber grundsätzlich bleibt die Kanzlerin hart.
Wir wollen, dass dieser Beitrittsprozess vorangeht, unbeschadet der Tatsache, dass es bei mir eine Skepsis gegenüber der Vollmitgliedschaft der Türkei in der EU gibt.
Hauptstreitpunkt ist der türkische Umgang mit dem EU-Mitglied Zypern. Auch Regierungschef Erdogan sieht da keine schnelle Lösung, bleibt aber optimistisch. Wir sind de facto schon in der EU, weil 5 Millionen Türken in den verschiedenen EU-Staaten leben. Aber wir wollen das natürlich auf eine rechtliche Grundlage stellen. Rechtliche Fragen spricht auch die Kanzlerin an, die hohe Zahl an inhaftierten Journalisten in der Türkei, und sie sagt volle strafrechtliche Aufklärung bei der NSU-Mordserie in Deutschland zu. Angela Merkel ist in Sachen EU-Beitritt einen Schritt auf die Türkei zugegangen. Ministerpräsident Erdogan hätte gerne etwas mehr Entgegenkommen gesehen, aber er weiß auch, sein Land müsste eine erhebliche Menge Hausaufgaben erledigen, und so wird vielleicht etwas mehr Schwung in die ins Stocken geratenen Verhandlungen kommen, aber ein EU-Beitritt der Türkei ist weiterhin in weiter Ferne.
Vielleicht wird er ja noch als Reformer in die Geschichte eingehen. Bereits mit seiner Rücktrittsankündigung tat Papst Benedikt XVI. Ja schon etwas, was 700 Jahre lang ein Tabu war. Heute, kurz vor seinem endgültigen Abschied vom Heiligen Stuhl, sorgte er wieder für eine Neuerung. Per päpstlichem Dekret änderte er die Regeln zur Papstwahl und ermöglicht so, dass die stimmberechtigten Kardinäle ihre Wahl, das Konklave, vorziehen können. Damit das wichtigste Fest der Christenheit, Ostern, nicht ohne kirchliches Oberhaupt gefeiert werden muss. Vielleicht hat es der Papst aber auch einfach nur eilig, die geheimen Untersuchungsberichte über das ganze Ausmaß des Vati-Leaks-Skandals in die Hände seines Nachfolgers zu geben. Susanne Hornberger über einen ereignisreichen Tag im Vatikan.
Nur noch 3 Tage, bis Benedikt XVI. Den apostolischen Palast verlässt und in den Ruhestand geht. Aber noch regelt der Papst wichtige Dinge für den Vatikan, für die Weltkirche. Bedeutende Entscheidungen wurden am Mittag in einer Pressekonferenz verkündet. Benedikt hat noch einmal ein sogenanntes Motu Proprio verfasst, ein apostolisches Schreiben, das in Briefform ergeht und administrative oder kirchenrechtliche Fragen behandelt. In diesem Erlass bestimmt Benedikt, dass die Wahl des neuen Papstes bereits vor dem 15. März beginnen kann. Ich überlasse dem Kardinalskollegium die Möglichkeit, den Beginn des Konklaves vorzuziehen, wenn die Anwesenheit aller wählenden Kardinäle feststeht. Die könnten also bei ihrem Treffen am Freitag nach Benedikts Rücktritt den Beginn des Konklaves auf einen Termin in der ersten Märzhälfte legen.
Es gibt Kardinäle, die sagen, lass uns anfangen, weil wir einen neuen Papst brauchen. Es gibt auch Kardinäle, die sagen, es gibt so viel zu besprechen, wir wollen erst mal reden.
Und es gibt einiges zu diskutieren. Zum Beispiel über das Ergebnis monatelanger Recherchen 3 von Benedikt beauftragter Kardinäle. Diese deckten angeblich interne Machenschaften im Vatikan auf. Dem Vernehmen nach geht es um dunkle Geldgeschäfte rund um das Vatikanische Geldinstitut IOR, homosexuelle Seilschaften Geistlicher bis hin zu damit verbundenen Erpressungsversuchen. Der Heilige Vater hat entschieden, dass die Ergebnisse der Ermittlungen nur ihm selbst und ausschließlich dem neuen Papst zur Kenntnis zur Verfügung stehen. Mit dem Rücktritt Benedikts verlieren zunächst sämtliche Kurienkardinäle, also seine Minister, ihre Ämter und Funktionen. Der neue Papst kann dann für sich entscheiden, wen er übernimmt und wen nicht.
Mit seiner mutigen Entscheidung wollte auch Papst Ratzinger klaren Tisch in der Kurie schaffen. Wir sind jetzt vor einem Neustart. Der neue Papst wird als erste Aufgabe die haben, eine neue Kurie aufzubauen.
Und noch eine Entscheidung hat Benedikt heute gefällt. Der Papst hat das Rücktrittsgesuch des Erzbischofs von Edinburgh, Keith O'Brien, mit sofortiger Wirkung angenommen. Aus Altersgründen, erklärte der Vatikan. Allerdings sieht sich O'Brien seit Sonntag Vorwürfen konfrontiert. Er habe sich in den 80er Jahren einigen Priestern in einer, wie es heißt, unangemessenen Weise genähert. Mit O'Briens Rücktritt sind es nur noch 115 Kardinäle, die den neuen Papst wählen dürfen.
Papst Benedikt XVI. Hat nun wenige Tage vor seinem Rücktritt die entsprechenden Vorschriften geändert. Damit kann die Versammlung der Kardinäle, aus deren Mitte ja der Papst gewählt wird, schon vor dem 15. März beginnen. An diesem sogenannten Konklave wird der Oberhirte der britischen Katholiken, Kardinal Keith O'Brien, nicht teilnehmen. Er trat heute wegen eines Sexskandals zurück. Maja Turic berichtet.
Eins steht schon jetzt fest über den möglichen Nachfolger von Papst Benedikt XVI. Ein Brite wird es nicht. Denn Keith Kardinal O'Brien hier links war der einzige britische Vertreter im Kardinalskollegium. 4 junge Priester hatten den 74-Jährigen beschuldigt, sich ihnen gegenüber unangemessen verhalten zu haben. Die Vorwürfe reichen bis in die 80er Jahre zurück. Ein damals junger Seminarist soll nach Medienberichten gesagt haben, O'Brien hätte ihm nach dem Nachtgebet Avancen gemacht. Im Einklang mit dem Kirchenrecht hat Papst Benedikt den Rücktritt von Kardinal O'Brien vom Amt des Erzbischofs von St. Andrews und Edinburgh angenommen. Kardinal O'Brien, der die Vorwürfe bestreitet, hatte zuletzt für Aufsehen gesorgt. Ausgerechnet der als konservativ geltende Kirchenmann forderte eine Abschaffung des Zölibats. Viele Priester kommen damit nur noch schwer zurecht. Sie wünschen sich eine Lebensgefährtin, die sie heiraten und mit der sie eine Familie gründen können. Papst Benedikt hat für seinen Rücktritt gesundheitliche Gründe angegeben. Viele Beobachter glauben jedoch, Finanz- und Sexskandale in der Kirche hätten den Papst zum Rückzug bewogen. Der Rücktritt O'Briens würde da ins Bild passen. Die vom Papst initiierte Untersuchung über Missstände in der Kirche hat eine Lawine ausgelöst. Das geht jetzt weiter und klopft sogar an die Tür des Konklave. Durch O'Briens Rücktritt sank die Zahl der Kardinäle im Konklave auf 115. Als möglicher Termin für die Zusammenkunft wird inzwischen der 10. März genannt.
Vatikan ist der schottische Kardinal O'Brien von seinem Amt als Erzbischof von Edinburgh zurückgetreten. Offiziell aus Alters- und Gesundheitsgründen. Der 74-Jährige nimmt damit nicht an der Wahl des neuen Papstes teil. O'Brien war zuletzt in die Kritik geraten. Nach Berichten britischer Medien soll er sich in den 80er Jahren jungen Priestern unangemessen genähert haben.
This is Mission Control, Houston. The Expedition 34 crew has had a full plate starting off another week in space on board the International Space Station, working on station maintenance tasks and scientific experiments while preparing for a new cargo ship to arrive and for a Soyuz spacecraft to depart in about 3 weeks' time. After a morning exercise session, Station Commander Kevin Ford went to work doing maintenance on the Amine swing bed. That's a technology demonstration payload that's testing whether the vacuum-generated amine system can be an efficient and effective system for removing carbon dioxide from the spacecraft's crew area. He will complete that task tomorrow, and the teams will then evaluate whether or not there is a need to return any parts of this hardware to the Earth on the next Dragon cargo ship. Also this morning, flight engineer Tom Marshburn was setting up for a planned Tuesday experiment run with the Spheres Vertigo experiment. That's a demonstration of technologies for visual inspection and navigation. The plan is to fly 2 Spheres satellites inside the station to construct a 3D model of another object, with the goal of having the satellites use that model to guide their own navigation during flight. Ford and Marshburn joined up later in the day to practice operations with Canadarm2 for this Saturday's grapple and berthing of the next Dragon cargo ship. This Dragon is due to launch from Cape Canaveral Air Force Station on Friday morning at 9:10 a.m. Central Time and arrive at the station on Saturday with 1,200 pounds of supplies and experiment materials. Flight engineer Chris Hadfield helped prepare for the Dragon by getting special communications system for Dragon operations set up in the cupola, as well as packing items that are going to be returned to Earth on Dragon in late March. He started his day doing science work, though, initializing the binary colloidal alloy test apparatus and photographing samples for that physical science investigation, and then looking over training materials for the material science investigation called coarsening in solid liquid mixtures. The experiment materials for CSLM are going to be arriving on Dragon. Flight engineers Oleg Novitsky and Yevgeny Tarelkin devoted the first part of their day into preparations for departure. They are to be undocking and landing in the company of Kevin Ford on March 14th, Houston time. And today, the 2 Russian crew members worked with the lower body negative pressure suit, which is a Russian apparatus that uses suction to pull fluids down to the lower extremities and simulate gravity, allowing crew members to evaluate their own orthostatic stability. Flight engineer Roman Romanenko spent part of his morning doing maintenance in the Russian segment of the space station and then transferring items to the Progress supply ship and updating the station's inventory management system. After lunch, he saw to maintenance with some storage batteries in the Russian segment, while Tarelkin cleaned filters in the ventilation system, and Novitsky updated the inventory for spare parts for the Electron. That's the Russian system that generates oxygen for the crew members to breathe. Expedition 34 crew is looking ahead to a week filled with continuing science research that's designed to improve life on Earth, as well as help prepare people for future deep space exploration. They'll also be taking care of the day-to-day operations and getting ready to receive a new shipment of fresh supplies to support the ongoing mission of the International Space Station.
NASA commercial partner Orbital Sciences successfully conducted an engine test of its Antares rocket at the Wallops Flight Facility. The rocket's dual HA-26 engines were fired for 29 seconds while the rocket was bolted down on the Mid-Atlantic Regional Spaceport Pad 0A. The test demonstrated the readiness of the rocket's first stage and launch pad fueling systems to support upcoming test flights. Orbital is building and testing Antares and its Cygnus cargo spacecraft under NASA's Commercial Orbital Transportation Services, or COTS program. Antares and Cygnus are scheduled for a test flight to the International Space Station later this year. This Friday, March 1st, is the targeted launch date for the next cargo resupply flight to the International Space Station. Liftoff of the SpaceX Dragon spacecraft's second resupply mission to the ISS is scheduled for 10:10 a.m. Eastern from Cape Canaveral Air Force Station in Florida. Dragon will be loaded with about 6 tons of crew supplies and materials for science research. Upon the unpiloted craft's arrival at the orbiting laboratory, Expedition 34 Commander Kevin Ford and Flight Engineer Tom Marshburn of NASA will use the station's robotic arm to grapple Dragon and attach it to the Earth-facing port of the station's Harmony module. When it splashes down in the Pacific Ocean off Baja, California later next month, Dragon will be carrying more than 2,300 pounds of experiment samples and equipment.
Final assembly and inspection of the Seedling Growth 1 experiment took place at NASA Ames Research Center in preparation for transport aboard SpaceX 2 Dragon to the International Space Station. Payload integration and engineering managers working with the European Space Agency, or ESA, came to Ames to perform the final steps of the process before the experiment containers are sent for launch. Designed and built at NASA Ames, the enclosures are completely self-contained, providing air, water, temperature control, and light for the seeds. Once on the space station, the enclosures are mounted in a centrifuge to test the effects of micro and low-gravity environments on the growth of the seeds. Seedling Growth 1 is one of several experiments being conducted by NASA and ESA to determine if specific plants can grow well enough in microgravity to provide astronauts with a complete and sustainable solution for long-duration space missions.
Hi, I'm Louise Jandura, Sample System Chief Engineer, and I'm here with your Curiosity rover report. This was a great week for Curiosity. We got to see something we've been waiting for quite some time. Sample in the scoop confirming that our first drill on Mars collected as we had expected. This was an important event as this is the first time a drill has been used on Mars to collect sample for analysis by instruments on the rover. We use these computer-generated images of different volumes to help us visually identify how much we've collected. We were able to estimate that we collected about 14 cubic centimeters of sample, or about a tablespoon, and this matched our expectation of what we would see in the scoop when we got to this point. Our drilling capability gives us the ability to get inside this rock. The first thing you notice about the material is that it's a different color. Gray, not the reddish-orange color all around us. That reddish-orange color is a sign of an iron oxidation, the kind of rusting process that's occurred all around Mars. Since we've been at Yellowknife Bay, Curiosity has done more than 100 MOLI images and more than 12,000 laser shots. You can see the telltale laser grid pattern from the ChemCam in this image. Additionally, you can see a fine-grained structure of this rock indicating either a mudstone or a siltstone. The next steps for the team are to finish processing this sample with Chimera and then put small portions into the SAM and Chemin instruments for analysis of chemistry and mineralogy. This has been your Curiosity rover report. Check back soon for more updates.
Hi, my name's Ray. This is really cool.
Ray Richmond from southern Maine was one of about 150 guests of NASA, most of them users of Twitter, Facebook, Google+, and other social media, who gathered at headquarters for a social about the groundbreaking research taking place daily on the International Space Station. Hundreds of experiments are being conducted in the station's unique microgravity environment that can benefit humanity while increasing our understanding of how humans can safely work and live in space for long periods. Bill Gerstenmaier, Associate Administrator for Human Exploration and Operations, was one of several featured NASA speakers.
We're in the process of starting to think about how much we can extend station. The physical hardware is probably good till 2028 or so. So we're trying to figure out when the right time to start talking about that is and start moving forward.
Marshall Porterfield is Director of Space Life and Physical Sciences Research and Applications. Tara Rutley is an ISS scientist.
There is nothing like it even on Earth. There's nowhere that you would find any kind of laboratory that would share material sciences facilities with life sciences facilities, with plants and humans.
I tell students that in order to do what I do for a living, you need to know math, you need to know science, you need to know engineering, because you have to take care of the machines that allows you to live in the environment that you're in, and this frontier happens to be space.
Also addressing the attentive group was physicist and former ISS resident Don Pettit, who was outdone only by 3 current space station crew members. From left, Flight Engineer Tom Marshburn, and Expedition 34 Commander Kevin Ford of NASA, and Canada's Chris Hadfield.
The whole purpose of this is figuring out how to safely get to space and back again. We haven't invented everything we need to invent yet, but hopefully soon everyone will be able to get this incredible experience that we're lucky enough to be part of.
Back aboard the station, Ford, Marshburn, and Hadfield hosted their own social media event, the first live hangout in space.
And what is that on Chris Hadfield's forehead?
Well, what he has on his forehead is actually a temperature probe.
The 3 astronauts took questions from the online community via Google+, Facebook, and Twitter. Viewers worldwide could also upload their video questions and watch the space-breaking event live on NASA Television's YouTube channel. Engineers at the Stennis Space Center have begun a new round of tests on NASA's next-generation J2X rocket engine. This next test series will continue to provide performance data critical to the engine's development. The J2X will provide upper stage power for NASA's new space launch system that'll send humans farther into space than ever before. NASA Administrator Charles Bolden has received the Candle in Military Service and Aeronautical Science Award from Morehouse College in Atlanta. The award recognizes exceptional achievement in a field by an African-American man. The Candle Award is part of Founders Day celebrations held each year at the alma mater of the Reverend Dr. Martin Luther King, Jr. The Marshall Space Flight Center co-hosted an exhibition at the Davidson Center in Huntsville, Alabama, called Robots to Rocket City. The event gave student teams from the area who will compete in the upcoming First Robotics Ultimate Ascent Challenge a chance to test their tenacious technologies before regional competition begins in late February. The students have built robots designed to score points by tossing discs through targets and by climbing pyramids.
When we received our kit of parts 6 weeks ago, we were very excited to start making our robot. We had been anticipating this before we started our build. We made a robot beforehand, a pre-season build, and we learned a lot about robotics that way.
NASA is especially interested in this type of activity because we're always looking for the best and the brightest, and these teams provide us that opportunity to see the students who are interested in science, technology, engineering, and mathematics.
First, for inspiration and recognition of science and technology inspires young people to be science and technology leaders by engaging them in exciting mentor-based programs that build science, engineering, and technology skills.
Smiling for me, everybody?
Associate Administrator for Education, Leland Melvin, recently visited the Aero Institute in Palmdale, California, where he was updated on education outreach efforts at the Dryden Flight Research Center. The Dryden education team earned Melvin's praise, as did the Institute, for its recent founding of the Palmdale Aerospace Academy, a school devoted to excellence in science, technology, engineering, and math. Both the Aero Institute and its academy are operated by a consortium that includes NASA, the City of Palmdale, and its local school district.
The school, the Aero Academy that we just talked about, is a perfect example of a partnership that's helping get these kids motivated and inspired. We have to make sure that the things that we're doing, the interventions that we're building, have relevance to the goals, or why are we doing it?
Melvin was also briefed on Dryden's online classroom outreach program, the Digital Learning Network.
We provide very unique opportunities for students across the board, whether it's connecting subject matter experts, astronauts, or even education specialists.
Melvin also toured the nearby Dryden Aircraft Operations Facility, home to the center's science-gathering aircraft aboard which students can fly.
Lisa Rowe, Langley Research Center Director, and Bill Robel, Director of Wallops Flight Facility, were in Richmond to speak with policymakers at Virginia's General Assembly about NASA's contributions to the Commonwealth's aerospace industry. The 8th annual Aerospace Day provided Rowe, Robel, and more than 20 NASA and industry teams the opportunity to outline for legislators the agency's economic impact on Virginia's aerospace industry. Also in Richmond, Rowe and U.S. Senator Tim Kaine visited the Math Science Innovation Center, where they spoke to 70 teachers from across Central Virginia at a NASA Aerospace Educator Workshop.
You are the folks that actually reach these students and make these students believe that they can make the impossible possible. And that's what we do at NASA.
My name is Todd Arnold. I'm the Deputy Director of Public Affairs at John F. Kennedy Space Center. I hired into NASA in 1989 as part of an accelerated training program for recent college graduates. As a member of the Kennedy Senior Management Team, I am responsible to ensure we have a highly skilled contractor and civil servant workplace on board to effectively communicate the NASA story, our past, our present, and our exciting future. I also assist in the effort to oversee operations on a daily basis for an active press site newsroom. In addition, I provide strategic leadership and vision to a team of individuals who are responsible for an array of public relations tools and techniques, including NASA television broadcasting, also news and photojournalism, web and social media presence, display management initiatives, as well as internal communications to the KSC workforce to help them remain informed so that they can be wonderful ambassadors for NASA. Here at NASA, I believe diversity is more than just a word. In fact, it is part of our core value system, which to me means it's not just a few people who are concerned about diversity, but every individual makes a difference and actively seeks out an opportunity to value the input of others. At an individual level, whenever I join a team for the first time, I first seek to learn a little bit about the backgrounds and experiences and education of the individuals I'll be working with. As a leader, I make it a priority to initiate efforts that will encourage individuals to partner and work together and leverage the strengths and backgrounds of others that are perhaps different from them. I really believe that at the bottom line, in order to get the best product, we must have every idea on the table.
More than 5,000 visited the Johnson Space Center's NASA exhibit in downtown Houston during the public events and activities held prior to the NBA All-Star Game. It was wall-to-wall fun at the four-day event. Fans had the opportunity to shoot, slam dunk, dribble, and learn about NASA's mission and how the work being done by the agency benefits life on Earth. The NASA exhibit included information on the International Space Station, commercial space transportation, and the next generation vehicle being designed for human space exploration, the Orion spacecraft.
2, 1. Booster ignition and the final liftoff of Discovery.
In the late afternoon of February 24th, 2011, Space Shuttle Discovery took off on its final mission into space. STS-133, the 35th shuttle mission to the International Space Station, delivered the permanent multi-purpose module, the Express Logistics Carrier 4, and Robonaut 2, the first dexterous humanoid robot in space, and now a permanent station resident. Discovery was the first orbiter in the shuttle fleet to be retired. Among the 180 people who flew aboard Discovery, the first female shuttle pilot and the first female shuttle commander, Eileen Collins, the first African-American spacewalker, Bernard Harris, and the first sitting member of Congress to fly in space, then Senator Jake Garn of Utah. NASA astronaut and amateur flutist Katie Coleman joined the Irish musical group The Chieftains on stage with the Houston Symphony during the band's 50th anniversary concert tour. Also sitting in from 240 miles above the Earth was Canadian astronaut Chris Hadfield on board the International Space Station. A longtime fan of the Chieftains, Coleman carried the band's penny whistle and Irish flute with her during her 2010 station expedition. Joining Coleman for the stage performance were fellow astronaut Dan Burbank and other members of an informal group of players known as Bandella that Coleman and Hadfield perform with on Earth.
A lot of people have asked how astronauts sleep at night. Well, we sleep in sleeping bags. We have our own individual crew quarters. I'm sticking my head out of mine right now. And if we're wearing pajamas, I'm wearing regular clothes right now, we put on our pajamas, and then we get into our sleeping bags like this. There's a great sleeping bag. And what's really cool about it is we can zip it up, and then we have little armholes. That way, if you want to, you can sleep with your arms floating. Some people like that. Some people like to get snugged up inside. But when we wake up, what I like to do is take my arms out. I start my day by getting on the computer and reading what Mission Control has sent up, reading procedures, and reading up on the news, just like you might do at home. And then it's time to get up. And it's off to start the day. But before our day starts, we do like most folks and make a quick trip to the restroom. So here's the station restroom. It looks just like the one on the Russian side. There's two on board. Let me show you how it works. We use airflow to take the place of gravity, and here's the seat. Doesn't look like much, but actually it's very effective because you don't need to actually sit on anything. Get that closed up. So number 2 goes in here, it stays in here, and we switch out this canister here when it gets full. And when it's full, we stow it in the Progress vehicle where we put a lot of our trash, and then that goes back in the atmosphere and burns up. For number 1, we turn on a fan, the same fan that starts up the airflow. And guys use a funnel like this. Women have an adapter that they use. And that's how you go to the bathroom in space. And so inside these walls, you have pretty much everything you need when you're in the restroom. We've got dry wipes and wet wipes and disinfectant wipes, pretty much anything you need. We also have something pretty special in the space station bathroom, and that is protective gloves and safety goggles. Now, the reason why we wear those is because behind these walls here are some very strong chemicals that treat our urine and help purify it to turn it into drinking water for us. So it all comes out here, it goes under those panels right there on the floor, and becomes our drinking water days later. It tastes great, it works well, and that means we don't have to fly up water to the space station to keep us alive up here. The station does it all for us.
This is Mission Control Houston. The International Space Station's Expedition 34 crew members showed progress on a range of science investigations on Tuesday, while also pressing ahead with preparations for Saturday's planned arrival of a new shipment of supplies on an unmanned cargo craft. Commander Kevin Ford started the day with a health status questionnaire That's just part of an ongoing effort for all of the crew members to gather information about how human bodies respond to being in a zero-G environment for an extended period of time. Ford then moved on to loading software on a laptop computer in the Columbus module for operations scheduled on Wednesday with the Cruise experiment. That's a European Space Agency investigation into ways to improve crew efficiency and autonomy, and it includes experimenting with voice commanding of the procedures interface. Flight engineer Chris Hadfield gathered more hardware today for later operations with an experiment known as coarsening in solid liquid mixture. The raw materials for that experiment are being delivered on the Dragon cargo ship. Later, he installed and checked out the centerline berthing camera in the Harmony Nader hatch window. That will support the berthing of the Dragon on Saturday after its grapple by Canadarm2. Flight engineer Tom Marshburn spent his morning supporting the Spheres Vertigo experiment. That's an MIT Space Systems Laboratory investigation employing some of the bowling ball-sized satellites to create a 3D model of another object. The intent in this experiment is that the model created by the satellites could then be used to inform the free flyers' autonomous navigation, that they could look at what was out there, create a model, and be able to use it right away in order to fly without impacting other objects. On the Russian side of the station, flight engineer Oleg Novitsky spent time today on a Russian TV documentary about life on board the station, and he was then joined by flight engineers Evgeny Tarelkin and Roman Romanenko for a Russian public affairs event this morning. All three of the Russian crew members moved on to routine station maintenance tasks throughout their Tuesday afternoon on orbit. After exercise and lunch on Tuesday, Commander Kevin Ford moved to complete a changeout of a gearbox in the Amin swing bed. That's a NASA investigation into whether a vacuum-regenerated amine system can be an efficient and reliable way to remove carbon dioxide from the environment of a space vehicle. Near the end of his workday, Ford will join flight engineers Chris Hadfield and Tom Marshburn for an educational event talking to students gathered at the Metropolitan Arts Institute in Phoenix. The Expedition 34 crew has a schedule full of science work this week as they continue preparations for the arrival of a new cargo ship on Saturday morning. It'll be delivering 1,200 pounds of cargo, including more experiment supplies as well as crew provisions to fuel the mission of the International Space Station.
Auch der Straßenverkehr von Houston hat so seine Tücken. Diese Kurve und eine Menge Alkohol trugen den Fahrer samt Geländewagen hoch hinaus über die Böschung. Im Flug rammte er, wie Augenzeugen berichten, zunächst das eine Hausdach, um dann im zweiten einzuschlagen, ohrenbetäubend mitten in der Nacht. Bam, bam, bam. Fahrer und Anwohner blieben unverletzt und der Wagen ist wieder gelandet.
Ziemlich bald wurde beides Realität. Afrikanische Länder wurden unabhängig und die Menschen bereisten den Mond. Dass aber bald danach auch Afrikaner auf den Mond wollten und sogar ernsthafte Vorbereitungen trafen, die damals auch vom Ausland ernst genommen wurden, weil nämlich Länder wie Sambia plötzlich reich waren, wegen der verstaatlichten Kupferminen. Das alles ist eine noch nicht erzählte Geschichte. Weil daraus nichts geworden ist, hat sich eine spanische Künstlerin mit dem Filmmaterial beschäftigt. Das zeugt von großen Plänen einer Mondreise der Sambier.
3, 2, 1.
We choose to go to the moon.
Wir haben beschlossen, in diesem Jahrzehnt auf dem Mond zu landen. Nicht, weil es einfach, sondern weil es schwierig ist.
Because they are easy, but because they are hard.
Die 60er Jahre. Alle wollen rauf. Und jeder will der Erste sein. Russen und Amerikaner überbieten sich gegenseitig. Die längsten Raketen, die riskantesten Manöver. Aberwitziger Weltraumschrott. Denn jetzt geht es um alles. Wer den Mond bezwingt, beherrscht die ganze Welt. Die Macht über die Menschheit wird oben neu verteilt. Doch da gibt es ein kleines Problem. Sambia mischt plötzlich mit. Aber bitte nicht so ein Stress. 1964, 3 Jahre nach Juri Gagarins Raumflug, gründet Edward Makukan Koloso auf einer Farm nahe der Hauptstadt Lusaka eine Nationalakademie der Weltraumforschung und Philosophie. Keine Weltallstreber. Die Vibes im Trainingslager sind ziemlich gut. Das hier ist also Ihr Raketenstartgelände. Können Sie mir sagen, wo die Rakete ist? Das ist unser Raketenstartgelände und die Rakete ist hier. Das wäre was. Sambia auf dem Mond. Bunte Klamotten und funky Tanzeinlagen anstelle des Modetrauerspiels und des dumpfen Pathos, das die Supermächte im All abziehen. Die Fotografin Christina de Middel hat die Story ein klein bisschen weiter gesponnen. Koloso hat aber wirklich existiert.
Er war ein Wissenschaftslehrer, der sich dafür entschieden hat, 10 Astronauten, 2 Katzen und eine Frau zu trainieren, um erst den Mond und dann den Mars zu bezwingen. Er erfand dafür ein Katapultsystem, also erst auf den Mond und dann mit einem weiteren Katapult zum Mars.
Die absolute Freiheit. Alles ist möglich. 1964. Sambia ist unabhängig geworden. Koloso will gerne einen höheren Posten in der Regierung. Er nennt sich selbst zum Leiter des Raumfahrtprogramms und möchte sich unersetzlich machen. Das Training zieht er knallhart durch.
Sie kletterten ein Seil hinauf und wenn sie ganz oben waren, dann schnitt er das Seil einfach ab. Dann hatten sie das Gefühl von Schwerelosigkeit. Oder, fürs gleiche Ergebnis, legte er Leute in ein Ölfass und ließ sie den Hügel hinabkullern. Es war die afrikanische Version des NASA-Trainings.
Christina de Middel ist Spanierin, lebt in London. The Astronauts nennt sie ihr Buchprojekt, für das sie unlängst für den Deutsche Börse Fotografiepreis nominiert wurde. In ihren Inszenierungen zeigt sie Sambias Raumfahrtprogramm als soziale Skulptur, als Performance, bei der die Kolonialmächte clever auf den Arm genommen werden. Die Unabhängigkeit Sambias setzt unglaubliche Energien frei. Die Traumata der Kolonialisierung waren noch nicht überwunden, auf den Straßen aber herrschte Euphorie.
Der ursprüngliche Plan war offenbar gewesen, dass dieser Start in den Weltraum im Nationalstadion von Lusaka während der Unabhängigkeitsfeier stattfinden sollte. Sozusagen als grandioser Knalleffekt dieser Unabhängigkeit, um zu zeigen, wir gehen jetzt, nachdem wir hier die Freiheit in unserem eigenen Land erkämpft haben, sozusagen in die ganz große Freiheit raus.
Sambia war jetzt unabhängig und ein großes, wichtiges Land. Und was machen große und wichtige Länder? Sie kolonialisieren. Damit Sambia wirklich ein wichtiges Land wurde, mussten sie halt irgendwas kolonialisieren. Also entschieden sie sich für Mond und Mars.
Das Inspirierendste an dieser wahren Geschichte ist die völlige Aufhebung von Schwerkraft oder Logik. Die Russen und Amerikaner sollen, munkelt man, kurzzeitig nervös geworden sein, als sie Wind davon bekamen, dass es in Sambia nun plötzlich auch ein Raumfahrtprogramm gab. Koloso war ohnehin davon überzeugt, dass er von Spionen der Supermächte beschattet wurde. Die reale Welt war plötzlich ganz weit weg.
1, 2, 3.
Als Konzeptkünstler war Koloso genial.
Nachdem er erfahren hat, dass diese Bitte um einen Kredit von $7 Millionen, an einer Stelle heißt sogar $700 Millionen, an die UN oder an die UNESCO, dass das nicht erfüllt werden würde, hat er dann ein Angebot an die Amerikaner angeblich gerichtet, wo er gesagt hat, wir können auch zusammen zum Mond fliegen, wir können uns daran beteiligen, aber entscheidend ist, dass wir unsere Fahne zuerst auf dem Mond einpflanzen.
Frage, wäre die Welt wirklich schlechter gewesen?
That's one small step for man, one giant leap for mankind.
Das Einzige, was gegen dieses Szenario spricht, sind unsere eigenen Vorurteile. Sambias Rakete soll zwar nicht geflogen sein, das Katapult war auch Schrott, aber der Laune im Team hat das nicht geschadet. Das Raumfahrtprogramm gab es trotzdem nur wenige Monate.
Sie hätten wahrscheinlich noch ewig weiter trainiert. Aber dann wurde das Mädchen plötzlich schwanger von einem der Astronauten und ihre Eltern kamen aus dem Dorf und holten sie zurück. Ende des Abenteuers.
Das Buch The Astronauts hat einen Hype um Christina de Midel ausgelöst. Im Eigenverlag veröffentlicht und mittlerweile vergriffen, wird es für bis zu 800 € gehandelt. Die Geschichte ist aber auch zu gut. Sambia führt die Supermächte richtig vor. Und das ist, ehrlich, ein tolles Kunststück.
Italien droht mitten in einer tiefen Wirtschaftskrise politisch handlungsunfähig zu werden. Weder das Mitte-Links-Bündnis von Spitzenkandidat Bersani noch die Mitte-Rechts-Allianz des früheren Regierungschefs Berlusconi haben bei der Parlamentswahl klare Mehrheiten gewonnen. Spekuliert wird bereits über Neuwahlen. Beide Parteienbündnisse zeigten sich heute aber gesprächsbereit. Auch die überraschend erfolgreiche Protestpartei des Komikers Grillo deutete Entgegenkommen an.
Es war ein bitteres Erwachen für viele Italiener am Kiosk heute Morgen. Italien hat jetzt nicht nur eine Finanz-, sondern auch noch eine politische Krise. Blockade, Unregierbarkeit, das Wunder Berlusconi. Der Wahlgang führte Italien nur noch tiefer in die Krise. Wir können nur hoffen darauf, dass die großen Parteien sich einigen, sonst geht's noch weiter bergab. Ich habe kaum noch Hoffnung auf Besseres. Auf ihm liegen jetzt vielleicht sogar zu viele Hoffnungen. Der Internetaktivist und Komiker Beppe Grillo hat seine Partei Cinque Stelle jetzt zur stärksten politischen Einzelpartei gemacht. Wir befinden uns in einer epochalen Zeitenwende der Kultur, der Politik, der Wirtschaft. Es geht um ein anderes Denken, nicht nur um Regierungskoalitionen. Im Parlament werde seine Bewegung Gesetz für Gesetz prüfen. In eine Koalition will er sich nicht einbinden lassen. Ganz anders Silvio Berlusconi. Nur knapp hat er den Wahlsieg verpasst. Er würde sich jetzt am liebsten in eine große Koalition einbinden lassen. So könnte er weiter mitspielen in Italiens Politik. Das aber will Pierluigi Bersani auf keinen Fall. Seine Partito Democratico hat im Abgeordnetenhaus die Mehrheit der Sitze errungen, aufgrund eines umstrittenen Wahlgesetzes. Im Senat muss er auf Koalitionen hoffen. Doch heute bot er noch keine an. Er setzt auf eine Initiative des Staatspräsidenten. Der Präsident der Republik muss sich ein Bild von der Lage machen. Er entscheidet am Schluss, wer mit einer Regierungsbildung in dieser schwierigen Phase beauftragt wird. Joachim Gauck hat Italiens Staatspräsident Giorgio Napolitano heute Abend in München zu einem Freundschaftsbesuch empfangen, zu Gesprächen über die politische Lage. Allzu viel Zeit sollten sich Italiens Politiker nicht nehmen, denn Europa wartet. Und zwar auf ein energisches Zeichen zur Lösung der Krise und nicht auf taktische Spiele.
Erst kurze Zeit im Amt hat der neue US-Außenminister Kerry bereits Deutschland besucht. Bei dem Treffen mit Bundeskanzlerin Merkel betonten beide die guten transatlantischen Beziehungen. Die USA, so Kerry, hätten mit Deutschland eine der stärksten und dynamischsten Allianzen. Beide Länder haben großes Interesse daran, Handelsbarrieren möglichst schnell abzubauen. So hoffen zum Beispiel die US-Autobauer auf Zollsenkungen. Zum Auftakt seiner Gespräche traf sich Kerry mit Jugendlichen.
Ein Empfang wie bei einem Heimspiel. Tatsächlich war John Kerry als Diplomatenkind zeitweise in Berlin zu Hause. Zu Beginn seines Besuchs spricht er mit jungen Leuten, sogar auf Deutsch.
Ich würde sagen, es ist wunderbar, wieder hier in Berlin zu sein. Danke.
Anders als Präsident Obama, der während seiner Amtszeit noch nie in Berlin war, kommt Kerry schon auf seiner ersten Reise hierher. Mit Angela Merkel spricht er über das geplante Freihandelsabkommen zwischen den USA und Europa, also die Abschaffung von Zöllen und Einfuhrbeschränkungen. Das ist etwas, das dabei helfen kann, die europäische Wirtschaft anzukurbeln, unsere eigene Wirtschaft zu stärken, Jobs zu schaffen für Amerikaner, Deutsche und alle Europäer und einen der größten Märkte der Welt hervorzubringen. Aus Sicht der Kanzlerin haben die Beziehungen zu den USA, wie sie sagt, übergroße Bedeutung.
Wir haben nicht nur gemeinsame Werte, sondern auch viele gemeinsame Aufgaben. Dazu gehören die Herausforderungen in Afghanistan, dazu gehört die Situation in Syrien, dazu gehört der Nahost-Friedensprozess, dazu gehört die Eröffnung von Verhandlungen im transatlantischen Freihandel.
Um sicherheitspolitische Fragen geht es vor allem, als Kerry anschließend den russischen Außenminister trifft. Der ist eigens hergekommen, um über die Lage in Syrien und den Umgang mit dem Iran zu reden. Was konkret vereinbart wird, verrät Kerry nicht, genauso wenig, ob das Gerücht stimmt, dass demnächst auch Barack Obama nach Berlin kommt.
Indes scheint US-Präsident Obama in Washington seinen designierten Verteidigungsminister Hagel durchsetzen zu können. Mit deutlicher Mehrheit beendete der Senat die Blockade Hagels. Damit ist der Weg frei für die entscheidende Abstimmung. Noch am späten Abend könnte der 66-Jährige ins Amt gewählt werden. In Ägypten ist ein Heißluftballon abgestürzt. Dabei kamen mindestens 19 Menschen ums Leben, unter ihnen viele Touristen. In der Nähe der Stadt Luxor war an dem Ballon offenbar eine Gasleitung gerissen. Durch die Explosion und eine anschließende Hitzewelle stieg er etwa 300 Meter hoch, bevor er zerplatzte. Der Ballonführer und ein Brite überlebten schwer verletzt, nachdem sie aus dem brennenden Korb gesprungen waren. Deutsche Urlauber waren nicht an Bord.
Bei starken Regenfällen in Mazedonien ist mindestens ein Mensch ums Leben gekommen. Brücken wurden zerstört, hunderte Häuser stehen unter Wasser. Mehr als 20.000 Menschen sind zurzeit ohne Strom. In einigen Orten warnen die Behörden davor, Leitungswasser zu trinken, da das Hochwasser die Brunnen verunreinigt habe. Die Meteorologen geben auch für die kommenden Tage keine Entwarnung.
Es ist ein gigantisches Projekt, eine Hommage an das berühmteste Passagierschiff der Welt. Die Titanic II soll ein exakter Nachbau des 1912 gesunkenen Originals werden. Aber dieses Mal, so verspricht der australische Milliardär Clive Palmer, werden wir die Reise zu Ende bringen. Es wird ein Denkmal für alle Menschen, die damals ihr Zuhause in Europa verlassen und auf eine Zukunft in Amerika gehofft haben. Sie hatten den Traum von Freiheit und daraus ist der amerikanische Traum geworden. 270 Meter lang soll die Titanic II werden und etwa 2500 Passagieren Platz bieten. Casino, Klimaanlage und Internet sind selbstverständlich, auch wenn der Geist von 1912 weitgehend erhalten bleiben soll. Gebaut wird der Koloss nicht in Belfast wie seinerzeit das Original, sondern in China. Über die Kosten schweigt der Macher. Es geht nicht um Geld. Ich kann es mir leisten und nur das ist wichtig. Palmer scheint einen Nerv getroffen zu haben. Angeblich gibt es schon über 40.000 Ticketanfragen für die Jungfernfahrt, die 2016 auf der Originalroute von Southampton nach New York stattfinden soll. Mehrere Interessenten sollen sogar bis zu $1 Million geboten haben, um dabei sein zu können.
Es ist 18:45 Uhr, hier sind die Nachrichten bei RTL und das sind einige unserer Themen. Jubel für Benedetto. 100.000 Menschen verabschieden den deutschen Papst bei seiner letzten Generalaudienz. Ja, es war der letzte öffentliche Auftritt von Papst Benedikt XVI. Deshalb strömten die Menschen heute Morgen auch in Massen auf den Petersplatz im Vatikan. 100.000 Gläubige wollten den deutschen Papst verabschieden. Morgen endet ja offiziell sein Pontifikat. Vor Beginn der Audienz wurde Benedikt im Papamobil durch die Menge gefahren und der 85-Jährige nahm sich auch Zeit, um einige Kinder zu segnen. Unter den Pilgern waren viele Deutsche. Unser Reporter Christoph Lang hat eine Gruppe aus Traunstein bei ihrem Abschied vom Papst begleitet.
Auf dem Petersplatz marschieren die Gebirgsschützen ein, powered by Blasmusik. Ein letztes Mal ist der Vatikan fest in deutscher Hand. Genau das wünscht sich der scheidende Papst. Da sind sich seine Landsleute aus dem Süden sicher.
Und wer der Mordsfreiheit haben, Sie werden sehen, der genießt es heute in vollen Zügen noch.
Im Laufschritt zu den guten Plätzen, es ist ja ein Tag fürs Geschichtsbuch. Sie haben 14 Stunden Busfahrt hinter sich, Schüler und Lehrer aus dem Traunsteiner Seminar, das einst auch Benedikt besuchte. Sie haben Verständnis für den Rücktritt.
Also für mich war es schon nachvollziehbar, weil man sieht es ihm ja auch an.
Und auch die 100.000 Menschen auf dem Petersplatz sehen ihm das an. Aus allen Ecken der Welt sind sie da. Es herrscht schon fast Volksfeststimmung. Dann aber wird es ernst, als Benedikt den Gläubigen dankt. Er habe gespürt, dass seine Kräfte schwinden, erklärt er und bittet um Verständnis dafür.
Schließlich danke ich allen, dass Sie meine Entscheidung, die ich vor dem Herrn zum Wohl der Kirche getroffen habe, mit Respekt und Verständnis aufgenommen hat.
Die Menge feiert ihn. Für den Moment sind die Probleme der Kirche ausgeblendet. Vati-Leaks, Missbrauchsskandale. Erneuerung ist nötig, aber dafür hatte Benedikt keine Kraft mehr. Da mögen der katholischen Kirche die Gläubigen in Scharen davonlaufen, aber das sind die Momente, die zeigen, wie viel Anziehungskraft sie trotz allem immer noch besitzt. 90 Minuten, dann ist Benedikts letzter öffentlicher Auftritt vorbei. Die Traunsteiner machen sich wieder auf den Heimweg und Kardinal Marx nimmt ein Schnäpschen mit den Gebirgsschützen. Mit der Entspanntheit wird es bald vorbei sein. Morgen verlässt Benedikt den Vatikan und dann läuft der Countdown für die Wahl seines Nachfolgers.
Jubel zum Abschied. Zehntausende feiern Papst Benedikt XVI. Bei seiner letzten Generalaudienz. Der Papst nimmt Abschied und weit mehr als 100.000 Gläubige sind auf den Petersplatz gekommen, um Benedikt XVI. Noch einmal zu sehen. Um dabei zu sein, wenn erstmals seit dem Mittelalter ein Papst aus eigenem freien Willen sein Amt niederlegt. Die letzte Generalaudienz ist ein Fest. Um Freude geht es und Dankbarkeit, weniger um eine inhaltliche Bilanz. Aus Rom berichtet Peter Südow.
Pater et Filius et Spiritus.
Es war ein bewegender Moment, als der letzte Segen gesprochen war. Minutenlanger Jubel folgte. Der Andrang zur letzten Audienz war gewaltig, darunter viele Deutsche, mit ein bisschen Wehmut, aber auch Verständnis für den Rücktritt.
Und bevor jetzt irgendwas dement oder was wird, ist besser so. Es tut mir natürlich schon leid, weil es halt doch ein bayerischer Papst war.
Ich finde es sehr gut. Ich finde es sehr vernünftig, hat vielleicht auch wirklich was mit dieser deutschen Vernunft zu tun.
Denn was nützt es, wenn er zu Deutsch im Bett liegt und die anderen Obrigkeiten bestimmen über ihn?
Selten war der Zuspruch größer in den knapp 8 Jahren seines Pontifikats. 150.000 Gläubige kamen heute. Er betonte einmal mehr, er ziehe sich nicht ins Privatleben zurück.
Ein Papst scheint allein, aber er ist nicht allein, wenn er das Schifflein Peti lenkt. Ich werde meinerseits den Weg der Kirche weiterhin im Gebet begleiten.
Am Ende dann gar stehende Ovationen für den scheidenden Papst, der diesen ungeteilten Zuspruch sichtlich genoss.
Er hat sehr unterstrichen, dass Christus die Kirche regiert und nicht der Papst. Das ist auch theologisch wichtig, denn irgendwie kann das auch ökumenisch helfen, dass man nicht mehr den Bischof von Rom als eine Art Kaiser sieht, sondern eben als ein Zeichen der Einheit.
Es war der letzte große öffentliche Auftritt. Morgen um 20 Uhr endet die Amtszeit des Papstes. Benedikt wollte nie Papst werden. Er hatte das Amt nur aus reinem Pflichtgefühl übernommen und gibt es aus dem gleichen Pflichtgefühl heraus wieder zurück. Das zeigt dreierlei. Für ihn ist die volle Leistungsfähigkeit für diese schwere Aufgabe unverzichtbar. Ein Papst kann das Gleiche tun, was die katholische Kirche von ihren Bischöfen und Kardinälen verlangt, nämlich im Alter zurückzutreten. Und schließlich nur ein neuer Papst hat die Chance für eine neue Kurie und damit für eine neue katholische Kirche insgesamt.
Who is chosen to be Pope? There are, I think, 5 runners that I can see sort of, if you sift through the 117 eligible cardinals, I believe only 115 will be here. There's a couple who are not well enough to attend. And I'll give you 4 S's and then I'll give you a Canadian at the end of this, because I know you're Canadian, you probably know more about this chap than perhaps I do. Leading off, Angelo Sola, who is an Italian. He's very close to Benedict as he was to John Paul II. Christoph Schönborn, who's Austrian. He's the strongest non-Italian European candidate. There's a chap called Odilo Scherer. He's Brazilian and he's the leading Latin American candidate to all intents and purposes. And Leonardo Sandri from Argentina. For much of the last decade, he in fact served as the third highest sort of Vatican member of staff. He was what's known as chief of staff. So you've got 4 S's there, 2 Europeans and 2 from Latin America. And then you've got a chap called Marc Ouellet. And he is a French-Canadian. He speaks Spanish as well. He spent 10 years in Colombia, so he may sort of talk to the Latin American group of cardinals who will be voting, as well as to the North Americans. It's going to be an interesting next couple of weeks. Of course, we'll find out more about Conclave on Friday.
Becky Anderson, live for us from Rome. Thanks very much. Well, as Pope Benedict prepares to step down, join us for a closer look at his nearly 8 years as pontiff, his resignation, and his legacy as the Catholic Church moves forward. That's The Legacy of a Pope. See it Thursday at 10:30 a.m. in London, 6:30 p.m. in Hong Kong, right here on CNN. A patch of farmland near Luxor, Egypt, is now the site of a makeshift memorial for 19 people killed in a hot air balloon crash. Flowers were laid at the spot where the victims fell to their deaths Tuesday. Investigators, meanwhile, spent the day trying to figure out what caused the tragedy. Our Reza Sayed joins us now with more from Luxor. Reza, how much do we know now about what happened?
Oh, Jonathan, we spoke to the local governor here today who was at the crash site, and he told us investigators are going to need at least another 2 weeks to figure out the exact cause. But according to the preliminary investigation, the cause could have had something to do with a terrible mishap that took place just seconds this balloon was to safely land.
Gut-wrenching reminders of what experts believe to be the deadliest hot air balloon accident ever. Basmela Yesin lives nearby. She heard the screams. Like any 7-year-old, she asked questions. I couldn't tell her there were people on fire, her father said. You can't. I was trying to convince myself it didn't happen. I couldn't believe it. At the crash site on Wednesday, a memorial ceremony for the 19 tourists who lost their lives, and a promise by the local governor to find out what happened.
We will let them know all the details. They have the right to know that.
A day earlier, a tourist captured the balloon's final moments. Investigators say the balloon was seconds away from landing when things went horribly wrong. This is the imprint the balloon left on the wheat field it crashed onto. This is how big it was. Investigators say as the balloon was coming down, a landing crew tossed over a landing cable that hit and broke off a gas pipe. That set off a fire that launched the balloon right back up in the air. At that point, the 21 people on board had seconds to decide, stay put or jump out. Investigators say 3 people jumped out, 2 survived. The rest stayed on board a balloon that was now on fire and out of control. Flames eventually devoured the balloon. What was left plunged to the ground, killing everyone on board. We came to save the people and the tank exploded. When it blew up, we stepped back.
It's terrible. You feel like nearly going to cry.
Local travel agent Osama Abdelghani is mourning the loss of the tourists. He also worries about the impact of the accident on local tourism. Tourism here in Luxor and elsewhere in Egypt was already hurting, with many restaurants and cafes sitting empty. That's because the violence and the unrest that came with the 2011 revolution scared a lot of visitors away. Government officials and business owners here are already on a campaign to remind tourists of what they call a solid safety record for hot air balloons.
This is the first time with victims, as we have seen, and that's why we think that this incident will not have a big or a decisive impact on the flow of tourists to our governorate.
For now, tourists visiting Luxor will not be able to ride its famed balloons until investigators find out the exact cause of Tuesday's crash. There are 8 hot air balloon companies here in Luxor that employ about 2,000 people. Most of those people are out of work until these balloons start flying again. And of course, the tourism industry is taking a blow, Jonathan, but you talk to people here and you get the sense that they're confident that this place is going to make a comeback. They say this place is too special for tourists not to visit, too many magnificent ancient ruins for people not to see. Again, they seem very confident that despite this tragedy, eventually they're going to bounce back, Jonathan.
You know, that having been said, nonetheless, all of our thoughts go to the final moments of the people aboard that balloon. I'm just curious about the ones who jumped off. Do we know? They couldn't have had very long to make up their minds. How high were they, and how badly banged up were they by the fall?
Yeah, they had seconds to decide, and as the balloon was ascending, one at a time, it seems, they decided to jump out. 3 jumped out. One of them didn't make it. Doctors performed multiple surgeries on him, but they couldn't save him. Then you had the Egyptian pilot who suffered severe burns in parts of his body. He's going to be okay as well. And then the second survivor, the British citizen, the lone tourist that survived. Remarkably, he's at a Cairo hospital with what doctors describe as minor injuries, but you have to think about the mental anguish he's going through because he survived and his wife didn't. His wife, one of the tourists that remains on board that hot air balloon, Jonathan.
Reza Sayah, live in Luxor for us. Thanks. Talked about around the globe, a number of beaches near Auckland are closed until further notice because of it. A fatal shark attack Wednesday. Now, they're rare in that part of the world. In fact, New Zealand has only recorded about 20 fatal shark attacks in 175 years. Ruth Wynn Williams has details.
Not far from shore, the 3.5-metre killer circles just moments after its deadly attack.
Yell out, a shark, and then we look up. Here we go, bloody everywhere.
The victim, in his 40s, is believed to be a local man, killed on an afternoon swim.
The shark was still attacking him. And then the shark stopped the attacking. He put his head up. We yelled out at him to swim over to the rock. And he raised his hand up. While he was raising his hand up, next minute, he went down. The shark pulled him down. He came up with his head underwater. And then we know he's dead.
Desperate witnesses could only watch in horror from the popular beach.
Shocking. First time seeing thing in real life. You know, you see in TV, you see in movies like Jaws and that, but happen in real life, man, I'm so shocking, man, scared.
3 teenage surf lifesavers from the Muriwai Club were patrolling the area. They alerted emergency services.
My team discovered the body, discovered the sharks were still there. It was a case of standing off for a while. We needed to put a bit of a plan in place.
But Westpac Rescue says the man was dead on arrival with 2 sharks circling his body in the water.
The police managed to distract the shark while we extracted the person from the water. So with the use of the local Muriwai Surf Club and some distracting noise from the helicopter, we managed to get the body into the surf boat and to shore.
My staff member has taken with him a firearm, and he has discharged his firearm towards the shark. We do not know at this stage whether or not he has hit the shark, but the shark rolled off and disappeared.
But they say they haven't found the shark, which rolled down into the water after it was shot. One News showed a shark expert our footage.
I can tell by the colour and the way it's swimming that it's most likely a white shark, a great white shark.
The man's wife and members of his devastated family gathered at the surf club, traumatised by the shock attack.
Well, you know, the family are very upset. They're very distraught.
And with the killer shark still somewhere in the water, helicopters will be patrolling the area. Meanwhile, Muriwai and its neighbouring West Coast beaches will remain off limits. Ruth Wynn Williams, One News.
Mit einem sehr persönlichen Auftritt hat sich Papst Benedikt XVI. Von den Gläubigen verabschiedet. Bei seiner letzten Generalaudienz bedankte sich der 85-Jährige dafür, dass sein angekündigter Rücktritt mit Respekt und Verständnis aufgenommen worden sei. Menschen aus aller Welt waren auf den Petersplatz nach Rom gekommen, um den Papst bei seinem letzten öffentlichen Auftritt zu sehen. Morgen Abend endet sein Pontifikat.
Entspannt und gelöst ist Benedikt XVI., als er zum letzten Mal mit seinem offenen Jeep durch die Menge fährt. Jeder kann sehen, dass ihm eine schwere Last von den Schultern fällt. Während der Generalaudienz auf dem Petersplatz gewährt der Papst ungewöhnlich persönliche Einblicke. Wer den Petrusdienst übernimmt, hat keine Privatsphäre mehr. Er gehört immer und völlig allen, der ganzen Kirche. Sein Rücktritt bedeutet jedoch nicht, dass er sich ins Privatleben zurückziehen werde. Er habe, so Benedikt, das Kreuz Jesu nicht verlassen und werde den Weg der katholischen Kirche auch weiterhin mit seinem Gebet begleiten. Der 85-Jährige begründet noch einmal seine Entscheidung zurückzutreten mit seinen schwindenden Kräften.
Schließlich danke ich allen, dass Sie meine Entscheidung, die ich vor dem Herrn zum Wohl der Kirche getroffen habe, mit Respekt und Verständnis aufgenommen hat.
Er zeigt sich zuversichtlich, dass die katholische Kirche Krisen überwinden werde. Und davon hatte Benedikt nicht wenige. Der Missbrauchsskandal, die erzkonservativen Piusbrüder oder Vatilix, der Verrat durch den Kammerdiener des Papstes Paolo Gabriele, der geheime Vatikan-Dokumente gestohlen hat. Diese schweren Zeiten verglich Benedikt mit einem Sturm auf dem See von Galiläa. Aber ich habe immer gewusst, dass Gott mit an Bord ist, dass das Schiff der Kirche nicht mir oder uns gehört, sondern ihm und dass er es nicht wird untergehen lassen. Nach seiner Ansprache genießt Benedikt den Jubel und Zuspruch der gut 100.000 Gläubigen, die diese letzte Generalaudienz Benedikts nicht versäumen wollten. Morgen an seinem letzten Arbeitstag verabschiedet sich der Papst von den Kardinälen. Anschließend zieht sich Benedikt zurück nach Castel Gandolfo, dann ist er Papst Emeritus.
Sie ist ihm anzusehen, die Erleichterung. Ein lange nicht mehr so gelöster Papst Benedikt XVI. Verabschiedet sich bei seiner letzten Generalaudienz von den Gläubigen auf dem Petersplatz im Vatikan. Und damit willkommen zu den Tagesthemen. Morgen Abend um diese Zeit wird sein Pontifikat Geschichte sein. Und was nach dem Rücktritt dann davon bleibt, das wird die Geschichte dann erst noch zeigen. Aber das spielte heute bei strahlendem Sonnenschein alles keine Rolle. Der katholische Oberhirte nahm sich Zeit für seine Herde, ein bewusstes letztes Mal als Pontifex Maximus zum Anfassen. Und da wollten so viele dabei sein, dass die Audienz nach draußen auf den Petersplatz verlegt wurde. Von dort Michael Mandlik.
Voraussichtlich wohl zum letzten Mal sah man heute eine ausgeprägt bayerische Farbenprägung anlässlich einer päpstlichen Generalaudienz in Rom. Auch wenn man sich nach der spektakulären Rücktrittsankündigung Benedikts darauf vorbereiten konnte, Scheiden tut weh.
Das ist einfach unser Papst gewesen. Tut mir leid, ich habe so Emotionen.
Das war schon sehr, sehr ergreifend und viele haben auch richtig geweint, ja.
Ein ebenso sichtlich ergriffener Papst nutzte noch einmal die Gelegenheit, um den Gläubigen in mehreren Sprachen die Beweggründe für seinen Rücktritt zu erläutern.
Schließlich danke ich euch allen, dass ihr meine Entscheidung, die ich vor dem Herrn zum Wohl der Kirche getroffen habe, mit Respekt und Verständnis aufgenommen habt.
Auch wenn er manch schwere Krise in seinem Pontifikat durchstehen musste, selbst am Ende stünden immer Zuversicht und Gottvertrauen, so Benedikt. Ich habe immer gewusst, dass Gott mit an Bord ist, dass das Schiff der Kirche nicht mir oder uns gehört, sondern ihm und dass er es nicht untergehen lassen wird. Morgen Abend schließlich endet das Pontifikat des Papstes aus Deutschland.
Susanne Hornberger in Rom. Wie haben Sie denn den heutigen Abschied des Papstes aus Deutschland erlebt?
Ja, man kann von einer einzigen großen Papstparty auf dem Petersplatz sprechen. Ich selbst habe Benedikt selten so entspannt, so locker, so gelöst erlebt wie heute. Man konnte förmlich spüren, dass eine große Last von seinen Schultern fällt. Benedikt hat in seinem knapp 8-jährigen Pontifikat ja auch sehr schwere Zeiten durchlebt. Wenn wir da an die erzkonservativen Pius-Brüder denken, den Missbrauchsskandal oder die WikiLeaks-Affäre im vergangenen Jahr. Und so war heute sehr gerührt über den Zuspruch und den Jubel der über 100.000 Menschen auf dem Petersplatz, die Fahnen schwenkten und minutenlang Beifall klatschten. Das hat ihn so berührt, dass ihm sogar die Stimme versagt, dass er sich bei allen bedanken wollte. Morgen ist sein letzter Arbeitstag. Er trifft um 11 Uhr die in Rom versammelten Kardinäle. Es heißt sogar, er werde sie einzeln begrüßen. Da wird wohl auch sein Nachfolger dabei sein, den wir ja noch nicht kennen. Das ist also eine sehr spannende Situation. Um 17 Uhr fliegt Benedikt dann mit dem Hubschrauber nach Castel Gandolfo. Dort wird er sich noch einmal am Balkon zeigen. Das ist die allerletzte Möglichkeit, sich von ihm als Papst zu verabschieden. Um 20 Uhr endet nämlich sein Pontifikat. Ab dann ist der Papa Emerito ein Papst im Ruhestand.
Also alle sind sich einig eigentlich inzwischen, dass Papst Benedikt sicherlich als einer der bedeutendsten Päpste der Neuzeit gelten wird. Man darf ja eines nicht vergessen, er hat nicht nur im Verlauf dieses Pontifikats Weichen gestellt für die Zukunft der Weltkirche, sondern er hat ja vorher auch schon während des Pontifikates seines Vorgängers Johannes Paul II., der immerhin über 25 Jahre, 27 Jahre im Amt war, maßgeblich dazu beigetragen, die Kirche zu führen. Er war ja der engste Berater des polnischen Papstes und hat da eben auch schon entscheidend mitgewirkt an den Geschicken der Weltkirche. So gesehen hat er eigentlich über 30 Jahre lang letztlich hier im Vatikan in der katholischen Kirche mitgearbeitet und entscheidende Weichen gestellt.
Morgen ist der letzte Arbeitstag des Papstes. Sein Pontifikat, wir haben es vorhin gehört, endet offiziell um 20 Uhr. Wie wird genau der Tag ablaufen?
Also morgen um 11 Uhr wird Papst Benedikt die Kardinäle treffen, die bislang schon in Rom eingetroffen sind. Also ein großes Kardinalskollegium schon. Er wird sich wohl auch von jedem Einzelnen verabschieden. Die Situation ist dann so, dass er wohl auch seinem Nachfolger die Hand schütteln wird, obwohl noch keiner weiß, wer es wird. Das bayerische Fernsehen wird übrigens morgen ab 10 Uhr wieder live von diesem Ereignis berichten. Und am Spätnachmittag dann gegen 17 Uhr wird Papst Benedikt mit dem Hubschrauber nach Castel Gandolfo in die päpstliche Residenz fliegen, um dort sein Pontifikat zu beenden. Denn in der Tat, Schlag 20 Uhr endet dieses Pontifikat und die sogenannte Sedis Vacanz beginnt. Und dann heißt Papst Benedikt Papa Emerito, emeritierter Papst.
Ja, vielen Dank. Soweit Michael Mandlik aus dem Vatikan.
Der Petersplatz ein einziges Fahnenmeer. Zigtausende sind gekommen, um Abschied zu nehmen. Doch eine Trauerfeier ist das hier nicht, eher eine Jubelparty. Mittendrin ein Mann, der das Bad in der Menge in vollen Zügen auskostet. Mit dem Papamobil fährt er die größtmögliche Kurve um den Petersplatz, sein letzter großer Auftritt. So viel Zuneigung hat Papst Benedikt XVI. Nicht immer erfahren. Ein Herz für den Papst und er Herz zurück. Auch aus der Heimat sind sie gekommen und spielen ihm ein letztes Ständchen.
Ein herzliches Vergelt's Gott sage ich allen Brüdern und Schwestern deutscher Sprache, euch, liebe Freunde, die zu dieser letzten Generalaudienz meines Pontifikats gekommen seid, und zu allen zu Hause. Und ich danke der Traunsteiner Blaskapelle, dass uns die Bayern-Hymne so schön gespielt hat.
Sein Rücktritt lässt niemanden in der Menge ungerührt.
Ja, absolut bewegend. Also es ist einfach irgendwie unvorstellbar, wenn man sich denkt, das war jetzt das letzte Mal, dass man Papst Benedikt gesehen hat. Schon sehr bewegend.
Und das trifft uns sehr, sehr tief, dass er jetzt einfach abgetreten ist. Aber wir verstehen es auch.
Es tut mir natürlich schon leid, weil es halt doch ein bayerischer Papst war. Wir haben ihn auch gern echt.
Und der Papst revanchiert sich, nicht mit einer Sonntagspredigt, sondern mit einem tiefen Einblick in sein Seelenleben, wie er sich am Anfang vom Amt überfordert fühlte, über den Verlust jeglicher Privatsphäre, über Zeiten, so Benedikt, in denen Gott zu schlafen schien. Ich bin zurückgetreten im vollen Bewusstsein des Ernstes und der Neuartigkeit dieses Schrittes. Die Kirche zu lieben heißt auch, den Mut zu haben, schwere Entscheidungen zu treffen. Doch noch immer gibt es Spekulationen um die wahren Beweggründe Benedikts. Im Zentrum steht noch immer die Wikileaks-Affäre um Intrigen, Korruption und Machtkämpfe in der römischen Kurie. Letzten Sommer übergaben 3 Kardinäle dazu einen Zwischenbericht an den Papst, ein inszeniertes Bild und offiziell vom Vatikan veröffentlicht. Die Botschaft: der Papst klärt auf. Im Dezember übergaben die Kardinäle das Schlussdossier in aller Stille. Eine Zeitung berichtete, es gehe nun auch um ein homosexuelles Netzwerk im Vatikan, um Erpressbarkeit. Entsetzt habe sich der Papst zum Rückzug entschlossen. Belege gibt es bisher nicht.
Das Schwulennetz, das ist Unsinn.
Seine Entscheidung habe der Papst längst vorher getroffen.
Indem das Papst Benedikt zurücktritt, gibt er auch seinem Nachfolger die Möglichkeit, einen Neustart anzufangen und eine neue Kurie aufzubauen und auch die Kirche neu zu bilden im 21. Jahrhundert.
Selbst Bischöfe und Kurienkardinäle aber halten Konsequenzen für nötig.
Das zum Wikileaks gezeigt hat, dass natürlich auch manches an der Organisation verbesserungsfähig ist. Das hat ja der Papst selber auch angesprochen, Papst Benedikt. Und das wird natürlich ein neuer Papst und auch mit neuen Kräften, denke ich, auch neu anpacken. Denn auch die Kurie, wie die Kirche, bleibt eine Ecclesia semper reformanda. Da ist immer zu schauen, wie wir es noch besser machen können.
Das Wikileaks-Dossier ist keine Hypothek für die Kirche, sondern wie eine Fotografie. Sobald der neue Papst sie in Händen hält, muss er entscheiden. Er kennt die Zusammenhänge und er muss die entsprechenden Konsequenzen ziehen. Ab morgen ist der Heilige Stuhl verwaist. Wer dort Platz nimmt, den erwartet kein leichtes Erbe.
Rom ist in diesen Tagen ja wahrlich ein Hort der Suchenden. Ein neuer Papst wird gesucht und eine neue italienische Regierung. Letzteres allerdings ohne, dass die Beteiligten in eine Kapelle gesperrt werden. Insofern darf man gespannt sein, was länger dauern wird, Papstwahl oder Regierungsbildung. Die politischen Verhältnisse in Italien werden vom Rest Europas natürlich mit Sorge beobachtet. Regierende drücken das dann diplomatisch aus, wie zum Beispiel Finanzminister Schäuble gestern Abend hier im Heute-Journal, als er sagte, wir sind alle nicht so richtig erfreut. SPD-Kanzlerkandidat Peer Steinbrück formulierte es heute weniger vornehm. Genau genommen sprach er aus, was andere nur denken. Aber darf man das, wenn man Kanzler werden will? Andreas Künast berichtet.
Klartext steht drauf, der Klartexter steht drunter. Peer Steinbrück gestern Abend in Potsdam, 250 Zuhörer, sonnige Stimmung. Der Kandidat antwortet auf eine Italienfrage.
Bis zu einem gewissen Grade bin ich entsetzt, dass 2 Clowns gewonnen haben. Ein beruflich tätiger Clown, der auch nicht beleidigt ist, wenn man ihn so nennt, Grillo, und ein anderer, der definitiv ein Clown mit einem besonderen Testosteronschub ist.
Als den definitiven Clown erkennt das Publikum ohne Mühe Berlusconi, einen Anhänger der blumigen Beleidigung, aber gerade von zigtausenden Italienern demokratisch gewählt. Italiens Präsident bleibt gar nichts übrig, als sein Treffen mit Steinbrück abzusagen. Giorgio Napolitano ist Kommunist, erbitterter Gegner Berlusconis und zurzeit auf Staatsbesuch in Deutschland. Ich sage nur, dass Italien andere respektiert, aber auch Respekt für sich selbst verlangt. Berlusconi selbst kennt sich mit Beleidigungen aus. Den SPD-Mann Martin Schulz hat er als KZ-Aufseher beschimpft, die Kanzlerin mit einem nicht zitierbaren Kraftausdruck. Auf den Italiener angesprochen, rutschte auch Merkel und Sarkozy ein undiplomatisches Lächeln raus. Nun diskutiert Berlin. Darf man Berlusconi einen Clown nennen? Durchaus, sagt die Koalition, aber nicht, wenn man Bundeskanzler werden will.
Man kann manches, was in Italien passiert, von hier aus kritisch bewerten. Aber wir werden in Europa nur gemeinsame Lösungen finden, wenn wir uns auch partnerschaftlich verhalten.
Ich habe gestern eine Veranstaltung gehabt, die nannte sich Klartext. Und ich habe Klartext geredet. So, nichts anderes. Und insofern habe ich das auch nicht wieder zurückzunehmen.
Steinbrück sagt noch, dass er den italienischen Präsidenten gut verstehen kann. Da klingt der Klartexter ein bisschen kleinlaut.
Der Deutschlandbesuch von Italiens Staatspräsident Napolitano steht ganz im Zeichen des Wahlausgangs in seinem Land. Schon bald nach seiner Rückkehr wird Napolitano den Auftrag zur Regierungsbildung erteilen müssen. Doch die Parteienbündnisse stehen ohne klare Mehrheiten da. Mit großer Spannung wird deshalb der politische Teil des Staatsbesuches morgen in Berlin erwartet. Für Irritationen am Rande sorgte SPD-Kanzlerkandidat Steinbrück mit Äußerungen über die Kandidaten Berlusconi und Grillo.
Italien ist empört. Die Zeitungen haben die Äußerungen des deutschen Kanzlerkandidaten morgen auf der ersten Seite. Steinbrück hatte gestern auf einer Parteiveranstaltung den Ausgang der Wahlen in Italien recht drastisch kommentiert.
Ich teile die Sorgen und auch einen gewissen Frust über das Ergebnis der Wahlen in Italien. Bis zu einem gewissen Grade bin ich entsetzt, dass 2 Clowns gewonnen haben.
Italiens Staatspräsident Napolitano, der selber weder Ex-Regierungschef Berlusconi noch Newcomer Grillo politisch nahesteht, hat daraufhin ein Treffen mit dem SPD-Kandidaten abgesagt. Kritik an Steinbrück kommt von den Berliner Regierungsparteien.
Herr Steinbrück hat die italienischen Wählerinnen und Wähler beleidigt und damit erneut Deutschlands Ansehen schwer beschädigt.
Nun, über Berlusconi hat jeder von uns seine eigene Meinung. Und dennoch stelle ich fest, man muss sich nicht auf das Niveau seiner Gegner herabbegeben.
In der eigenen Partei findet man die Formulierung des Kandidaten auch nicht so ganz gelungen, unterstützt Steinbrück aber inhaltlich.
Er hätte auch formulieren können, dass 2 Leute gewählt wurden, die offenbar Schwierigkeiten haben im Umgang mit demokratischen und rechtsstaatlichen Regeln. Und das ist viel gravierender als der liebevolle Begriff Clown.
Und Steinbrück selber sagt heute:
Ich habe gestern eine Veranstaltung gehabt, die nannte sich Klartext. Und ich habe Klartext geredet. So, nichts anderes. Und insofern habe ich das auch nicht wieder zurückzunehmen.
Napolitano hat inzwischen mit Steinbrück telefoniert. Morgen wird er in Berlin mit der Bundeskanzlerin reden über die schwierige Regierungsbildung in Italien und die Auswirkungen auf den Euro.
Chuck Hagel ist der neue Verteidigungsminister der USA. Der Wunschkandidat von Präsident Obama legte im Pentagon seinen Amtseid ab. Hagel sagte, die USA stünden vor enormen Herausforderungen. Sein Land wolle sich weltweit engagieren, aber anderen Ländern nichts vorschreiben. Obamas Entscheidung für den Republikaner stieß ausgerechnet in Hagels eigener Partei auf Widerstand. Erst nach wochenlangem Streit gab der Senat gestern grünes Licht für die Personalie. Der Schriftsteller und ehemalige Widerstandskämpfer Stéphane Hessel ist tot. Der Autor des kapitalismuskritischen Bestsellers Empört euch starb in der vergangenen Nacht im Alter von 95 Jahren in Paris. Politiker und Intellektuelle würdigten Hessel als großen Humanisten und Kämpfer für soziale Gerechtigkeit.
Immer streitbar bis ins hohe Alter. Stéphane Hessel, 1917 in Deutschland geboren. 7 Jahre später wird Frankreich seine Heimat.
Ich bin in Berlin geboren und das bedeutet etwas, denn ein kleiner Berliner bleibt immer ein kleiner Berliner. Etwas frech, nicht wahr?
Gegen die Nazis kämpft er in der französischen Resistance im Widerstand, wird in deutsche Konzentrationslager deportiert, unter anderem nach Buchenwald. Stéphane Hessel gelingt die Flucht. Nach dem Zweiten Weltkrieg macht er Karriere als französischer Diplomat, ist einer der 12 Autoren der UN-Menschenrechtscharta. Sein fulminanter Essay Indignez-vous, Empört euch, macht ihn 2010 weltberühmt. Das kleine Protestbuch wird zu einer Art Bibel für Anhänger der Occupy-Bewegung.
Ich setze mich jetzt ein, immer, wo auch immer Menschenrechte und die ursprünglichen Werte, mit denen ich groß geworden bin, verletzt sind.
Ein lebenslanges Engagement. Was er sagte, hatte Gewicht.
This is Mission Control, Houston. Wednesday has been a science day for the crew on board the International Space Station, working on research in a range of disciplines to advance the mission of the station while getting set to receive a shipment of supplies that will continue to support that mission. Today, Commander Kevin Ford spent a part of his morning working on elements of the cruise experiment. That's a European Space Agency technology demonstrator of possible ways to improve a crew's efficiency on orbit. Ford worked with a voice-activated procedure viewer and the procedural displays, testing ways in which a crew can be more autonomous as well as more efficient in their work, something that'll be even more critical for future explorers on missions where communication with Earth will be harder than it is for today's crew. Flight engineer Yevgeny Tarelkin and Roman Romanenko worked this morning with the lower body negative pressure suit. That's a routine for Russian crew members who are preparing to come home. That suit, which is just the lower body, uses suction to simulate gravity and allows cosmonauts to test their orthostatic tolerance after months in zero-G. Flight engineer Oleg Novitsky, who is going to be coming home with Tarelkin and Kevin Ford in a couple of weeks, he spent the morning working on maintenance and then moved on to replacing some condensate removal lines in the Russian section of the space station. Flight engineer Chris Hadfield and Tom Marshburn worked together in the early part of the day on the integrated cardiovascular experiment. That's looking at trying to quantify the decrease in the size of a crew member's heart muscle over time while in weightlessness. Crew members do exercise, and they're assisted by a second crew member who are performing examinations of them to gather the data for the investigators on the integrated cardiovascular experiment. All of the crew members had one of their scheduled exercise sessions before the lunch break and a second afterwards. It's a combination of exercise, whether it's treadmill or stationary bicycle or strength work on the advanced resistive exercise device that serves the crew members to help maintain their physical fitness and counteract the muscle and bone loss that they suffer during a time in the environment where their body doesn't even have to fight against the pull of gravity. After lunch, Romanenko, Hadfield, and Marshburn had a routine emergency descent drill. They're not scheduled to return to Earth until May, but a practice descent drill in the case of an emergency is a standard thing for crew members on board the station. Novitsky and Tarelkin gathered equipment that's associated with a new Russian plasma wave apparatus that's going to be installed on the outside of the station during a spacewalk by Romanenko and cosmonaut Pavel Vinogradov in April. That apparatus will measure the electromagnetic field around the space station. Kevin Ford spent time in his afternoon setting up the combustion integrated rack for its experiment operations, and then we'll move on to join Hadfield and Marshburn for a conference with specialists on the ground about cargo operations with the Dragon spacecraft. Today, the International Space Station Mission Management Team conducted its launch readiness review, and all are go for the second operational mission of the supply ship provided by SpaceX. It is due to launch from the Cape Canaveral Air Force Station on Friday morning at 9:10 a.m. Houston time, and will be grappled and berthed to the station's Harmony module on Saturday morning. Hatches to the Dragon are due to be opened up on Sunday, so the crew can begin to unload 1,200 pounds of supplies and experiment equipment to be found inside. Then, over the course of about the next 3 weeks, they will also be loading about 2,300 pounds of science experiment samples and other returning equipment before the Dragon departs and lands in the Pacific Ocean on March 25th. Ford, Hadfield, and Marshburn will be enjoying some off-duty time on Thursday and Friday while they finish packing return items, and get in some final training flying the Canadarm2 before they go to work this weekend, a busy weekend of operations with the latest visitor to the International Space Station. Earlier today, Tom Marshburn spent a good bit of time assisting with a ground-commanded activity. Saw a couple of small satellites flying inside the station to construct a 3D model of another object. The Spheres experiment is familiar to those who've been following the International Space Station program. It got started on the space station during Expedition 8. But today's activity was part of the Spheres Vertigo experiment. In this case, Vertigo stands for Visual Estimation and Relative Tracking for Inspection of Generic Objects. And to learn more about this project, I'm joined now by Brent Tweddle. He's a PhD candidate at the Space Systems Laboratory at MIT in Cambridge, Massachusetts. He's a member of the Spheres Vertigo team that ran this morning's test run and is, in fact, the man who was on the radio talking to Tom Marshburn during the activity. Brent, good morning. Was this your first time talking to astronauts in space?
Good morning. Yeah, actually, this was. It was an early morning for us, but it was really great to talk to Tom and see him work with our hardware for the first time on orbit.
Tell me how you got involved in the Vertigo project.
So I've actually been involved for a good number of years. It started back in when I first came into grad school. My advisor, Professor David Miller, sort of said to me, look, we've got these Spheres satellites that are on the International Space Station, and we want to put cameras on them and go. So it was sort of a blank slate that I had to go through, and we had a little bit of funding. We were partnered with the Naval Research Lab in Washington, D.C., and we built up a good ground prototype of this and tested it out with a couple of visual navigation algorithms. Then after that program actually was quite successful, we got some follow-on funding from the folks at DARPA to take the hardware that we built and transition it to an operational system that could actually be launched to the International Space Station. So that was a big part of my PhD, and we formed a team with a whole bunch of other sort of organizations, Aurora Flight Sciences in Cambridge, Massachusetts, and then we were integrated by STP and NASA Ames into the NASA process. And there were a lot of grad students and undergrads that joined the team, and we sort of put everything together, shipped our hardware, I think it was last August of last year in 2012, and it launched in October, and today was our first operations that went very well.
I want to get you to tell me about how so. Explain for those who are familiar with seeing these Spheres satellites commanded to fly in formation on board the station. How does the Vertigo experiment differ from what we've seen before?
Right, so Spheres is a system, as you said, for formation flying, but it relies solely on a set of ultrasonic beacons that are installed inside the International Space Station to figure out where it is within the crew volume. And one of the things that we're looking at doing and sort of opening a whole bunch of research possibilities is to add a pair of stereo cameras, much sort of like the human eye set of stereo, or the stereo set of human eyes, to actually be able to see, perceive, and understand its world visually. And we use that information and communicate that information to the Spheres satellites using a package that's called the Vertigo goggles. And these goggles are they're sort of a 1.6 kilogram. They're almost like a netbook computer in terms of they have processing power, cameras, Wi-Fi device, a battery on board, and they're their own sort of little intelligence block that sticks on the front end of the Spheres satellites and allows it to see the rest of the world that it wants to navigate through.
You provided us some pictures of that equipment that was used today, including the hardware that you've just described. It for all the world looks like you put eyes on the front of this sphere. Is that right?
Yeah, and it's sort of funny the way that kind of fell out. I mean, we weren't trying to make it look like anything, but a lot of people have commented it kind of looks like a Wall-E figure, but it really just fell out of the requirements of being able to see, build a three-dimensional map, having some processing power that we had, and putting some batteries and cameras on there, and we sort of followed the high-level system requirements, propagated it down to a design, and actually, in all reality, not all that surprisingly enough, it looks like sort of a human face when it is flying around the ISS.
Maybe the reason that our eyes look that way because it works.
Yep, I mean, that if it works, go with it.
And the trick, of course, is how you make this work. Can you give us a high-level explanation of how those goggles take in information that would help construct this model?
Yeah, so that's an interesting question. What we do is we run through basically an inspection algorithm where for this particular case, we're looking at an unknown object that we don't really know much about, but we want to build a three-dimensional model that we can use for relative navigation. So we fly around the other object, taking photos in sort of a trajectory, and then we match up what's known as feature points on each of the objects. They sort of look like corners or sharp edges or things that are very distinguishable that we can match from frame to frame and from time step to time step. We put that all through various types of optimization engines, and we can come out with a geometric location for each of those features and start to build up a dense model, a lot like you would have a CAM-CAD model of the system from the visual information that is reprojected through the stereo cameras. That makes some sort of sense.
It does. And then is the data stored in the sphere itself, or transmitted to some other computer that's processing it, putting it together?
All of the processing for this is done on board the Vertigo goggles, and that actually led to a fair amount of effort in the engineering design. Is that we had to put a much faster computer on inside the goggles than the Sphere satellites have had for years. So that computer is actually it's kind of a standard 1.2 gigahertz Linux computer that's embedded and customized in a couple of different ways, but we store it all locally, and we do the navigation with respect to that map all on board the actual satellite and all autonomously.
The next step then would be presumably getting that data to some piece of hardware that can crunch it.
Yes, we are. So once you actually have the model on there, then the algorithms are such that the goggles can actually crunch on that model and use that for navigation and high fidelity positioning and pointing if it wants to go and rendezvous or dock or then interact with the system.
So it's a very short turnaround. It's almost a real time. Take a look and make a map.
Yep, and that's exactly the idea. We, from a high-level perspective, you don't want to have the robot that is interacting with an unknown object in space, having to radio all of its information down to the ground and then radio it back up. The advantage of having a fully autonomous closed-loop system is that it thinks for itself on the fly, and even when there's very large time delays. And that obviously has appealing characteristics, but it also makes the problems very hard, and that's what the challenge is with this research.
Why is this worthwhile? Why would it be valuable to have a free-flying satellite be able to make such a map?
There's a lot of different and very good cases for looking at other objects in space. One of the ones that DARPA is interested is in going in and recycling old aperture satellites, which are some of the most expensive parts to launch, and refurbishing them for new spacecraft. And this is part of part of the DARPA Phoenix program, where they're trying to build up a new satellite by only launching the smallest elements, which is a really cool idea of basically space recycling, as best as I understand it. There are a couple of other applications, things like going to asteroids, which is sort of one of the NASA plans, and sort of understanding how that asteroid looks as you navigate around it and how it works even as it's tumbling and spinning, which is one of the additional challenges that you have in a space environment.
We're showing the NASA TV audience some video from the test this morning and seeing one sphere flashing lights at another one. How did the test go this morning?
So the hardware and the operational software part of it went great. It all worked the way the system worked when we sort of handed it over. Everything checked out fine, and so we have good good certainty that the hardware is working on orbit. The algorithms that were meant to do the circumnavigation and inspection worked pretty well, and we could see that they were going along the way they should, but they do need a fair bit more tuning and refinement. But that's exactly why we do these types of programs with the International Space Station, because we will be getting the data down as soon as tomorrow, be able to rehash and refurbish our algorithms, and we're hoping to operate actually on March 12th with a more refined version of those algorithms and get some of those milestones checked off.
So that's the next step, is another run just in a couple of weeks. Yeah,
it's a very short turnaround time, and that's really one of the benefits of operating with the crew on board the International Space Station.
And Dr. Marshburn was helpful?
Oh yeah, he was great. I mean, I can't say enough good things about how he operated in this test session. He was very, very professional, very thorough. I mean, all the results. It surprised me how well he did with this hardware that has never been turned on or operated even before. One of the tricky things is that we actually had to do a recalibration of the cameras to get high quality data, and it was a procedure that we were sort of holding our breath, that we weren't sure how easy it would be for the crew to do, but he just nailed it and got it right on, and we should be able to get good results now that we have that calibration very good.
Well, Brent, we'll be looking forward to seeing another run in a couple of weeks and find out how well it's improved, how well we've learned from the first time.
Yeah, no, we're all definitely very excited, and there's still plenty of work for us to do.
Great. Brent, thank you for helping us learn a little more about this morning. Brent Tweddle is with the Space Systems Laboratory at the Massachusetts Institute of Technology and a member of the Spheres Vertigo team.
Well, great. Thanks for having me.
We've been mentioning a variety of the kinds of experiments that International Space Station crew members perform, and those experiments come in a wide range of their different scientific disciplines, some of it very deep and theoretical, some of it designed to learn more about how people can live in the space environment. And some of it is demonstrating concepts for technology that could assist future exploration to deep space. And today, Commander Kevin Ford performed one of those latter experiments. You're seeing some video that we recorded that was downlinked earlier today of Ford performing a European Space Agency investigation that's aimed at improving crew operations efficiency and their autonomy as well. Joining us this morning to talk more about CRUISE, which is Crew User Interface System Enhancement, is Michael Wolf, a senior software engineer and ESA's lead and co-investigator for the CRUISE experiment, speaking with us this morning from his office at the European Space Research and Technology Center in Noordwijk in the Netherlands. Michael, tell me about the background of this project and how you got involved in it.
Okay, good morning, Pat, first, and thanks for the chance to chat with you about this. Our group here at ESA and our industrial colleagues, we've been interested in improving the onboard user interface for a long time, essentially trying to make astronauts' performance improve and also get better, say, user satisfaction for when they're actually working up there. And the streams we've been doing this in is technology demonstrations, say, building block demonstrations, but we've also been thinking, say, more in larger term of trying to establish a path towards building a smart assistant, say an e-partner, to actually give a more broader support. I'd say that what we did today, the commander session with CRUISE, is a building block type of technology demonstration and also an operations demonstration.
Well, maybe a way to help understand this is to turn that question on its head. What is the deficiency in the way the crews operate now? What do you see in the current way that they operate that should be improved?
Well, first, I don't think it's only deficiencies. We do have some advantages with the electronic systems on board. I mean, we can carry less paper, and thereby we get things a little bit more cost-effective operations. But certainly, one deficiency is, of course, that it takes a long time to spin in technologies from ground into the space segment, since all validation and safety aspects has to be taken into account. And this is what we're trying to do. And especially, we've seen that for manual tasks, in-flight maintenance tasks type of things, the user interface that is provided today for the astronauts is not so-called task transparent enough, which means the user interface often gets in the way while they are doing their primary tasks, say adjusting a valve or doing a repair activity.
Their ability to consult the instructions is hampering them from doing the actual work.
That's correct. And we also seen that the operation, the actual instructions for avionics task, when you actually have to tune something deep down in the system, you usually have the operations content, the procedures, separated from the flight software displays. And one of our sub-experiments today is to go towards a design where we have both operations instructions and flight software parts in the same flow in the procedure, something that is not yet available on board.
We've noticed that part of this procedure has to do with the use of voice activation, and there's a piece of hardware that we saw in the video where that Kevin Ford was wearing, a little headset microphone, which is not brand new technology. Are you just trying to make better use of what already exists, or are you trying to develop something new?
I would say to a large extent it is a spin-in type of experiments. We're spinning in from the consumer market and what's available for us here down on ground. And indeed, as you noticed, it's a fairly normal microphone and headset he's using there. So, but a voice dialogue has not been available for crew before. There has been other experiments. Our NASA colleagues have indeed experimented with this, but moving from experiments towards actual operational interfaces has not yet taken place. And we're trying to learn more about this so we can, based on this experiment, we can design systems that are that this will actually work on.
And I noticed in some of the paperwork that one member of your science team is Italian astronaut Paolo Nespoli, an ESA astronaut. Has having his point of view, a veteran station crew member's point of view, helped you in your development?
For us, yes, it's always very important to have end users involved, as astronauts involved. And Paolo and also his other colleagues at European Astronaut Centers, for example, Frank de Winne, has helped us both in the development and in the testing. So it's not only for the final test, but we need all stakeholders, astronauts and operations engineers, to be involved throughout development and testing to get a product that we think can do the job that we expect it to do.
So how did it go this morning? Kevin Ford was working with in two sessions on the timeline here, with a procedural display and then with a voice-activated procedure viewer. Tell us how today's work went.
I could only follow it the same way you did, which was the voice loop and from video, and certainly the procedure display looked to go very, very fine. We were on time and we had the whole task completed. We will be very interested in seeing the data generated. Later on, it was the voice-activated procedure viewer that we did, and that task was selected to be as realistic as possible. So this was an in-flight maintenance task, and with in-flight maintenance task comes also, say, other issues. And I think there was one issue with the tools here. And that means overall that there was some time pressure, I believe, and a high workload on Kevin. And in such a situation, and this is part of what we want to learn about also, it is excellent to be able to do one thing, to do user interaction in more than one way, so voice and point and click. But it's, of course, easy to do the most the one that you're most used to first. So I believe we got some good voice commanding in there, but we have a mixture of both voice commanding and traditional commanding. So again, when we look at the data there, both the objective and the subjective data, it will be very interesting to see.
And I believe that Chris Hadfield is going to do a similar type of run for you later on, right?
That's correct. So thereby we cannot say, of course, that we have a full statistical, can do a full statistical analysis, but with two astronauts performing our experiment, we will have a much better idea than only the ground-based experiments that we've done before. That hopefully, we get the kind of insight we need to design these systems.
So what's the next step? After Ford and Hadfield do this, you've said you need to look at the data, but what will be the next step for you and your team?
Yeah, after analysis, I think we're heading towards more type of building block experiments. For example, having this so-called procedure viewer on a state-of-the-art tablet, and also adapt its user interface to something that we're more used to on the ground. This is also in cooperation with our NASA colleagues and the procedure group there. We are also looking at more wearable systems, so you should not have to be floating back and forth to your laptop for any reason, but you should be able to bring your equipment with you to your workplace, and we hope we can test these things in the near future. And of course, with voice, which is one of the new natural user interfaces, we hope we can implement a full dialogue. This time we only had full voice dialogue. This time we only had voice commanding, but the system itself was, in a sense, silent. It didn't really speak back.
Let's see. Is that the goal then in the long run? Are you trying, once this is all developed and implemented, are you trying to create a system where, like in science fiction, where people can talk to their computers and the computers talk back?
Well, you could say you could have that science fiction picture, a friendly HAL, but of course it's not only that you can talk, it's also what you're talking about. So it should be robust and resilient e-partner or crew assistant that can help the crew member, the astronaut, and the astronaut team to work together and share the tasks properly and give appropriate support depending on the individual's needs. And that is, then we've gone beyond building blocks and actually build a system. And hopefully we have a chance to do some of testing for this kind of system to support more autonomous operations when ISS can be used as an analog for a mission beyond low Earth orbit.
That sounds great. And actually, I was thinking more of talking to the Star Trek computer rather than HAL, but it's the same, same principle.
In principle, it should work that too.
Michael, I appreciate your taking the time to bring us up to speed on this. It's very interesting. Thank you.
Thank you very much for being able to come on.
Michael Wolf is a senior software engineer with the European Space Agency. He's the lead and co-investigator for the CRUISE experiment.
Station, this is Houston. Are you ready for the event?
Houston, are you ready for the event?
Houston, the International Space Station is ready for the event.
CTV Studios, this is Mission Control Houston. Please call station for a voice check.
Station, this is Canada AM host Beverly Thompson. How do you hear me?
Beverly and Canada AM, I hear you loud and clear. How do you hear me?
I can hear you very well, Commander Hadfield. Thank you so much for doing this.
It's a real pleasure. I've been lucky enough to visit with you folks several times, and to be able to talk to you today from this place doing these things is a real privilege.
Well, and it's so great for us to be able to catch up with you. You know, we do a lot of interviews all over the world. This is our first, my first certainly doing one out of this world. I have to ask you to tell us kind of, you know, not where in the world you are, but literally, where are you in the International Space Station?
The International Space Station is enormous. I mean, it's a lot bigger than most people think. It's a bunch of laboratories bolted together. I'm currently in one of those laboratories. That's the universe just out the window. We're inside the Japanese laboratory. Just behind the camera is the European laboratory. The American laboratory is over there. The Russian segment is down there. And then all across it here, bigger than 5 hockey rinks, is the whole space station. It's a big place, and we're just in one little corner of it here right now with experiments all around me.
You know, and it's just, even though we know you're in weightlessness, it's still pretty funny to see a microphone just kind of sitting, floating around. I have to ask you, tell us how you spend your day, your average day there.
Average day in space, you wake up at 6 a.m. We live on Greenwich time. They had to kind of split the pain between Mission Control in Moscow and Mission Control in Houston. So they chose London, England, about halfway between. So we wake up at 6 a.m. London time. You have an hour and a half or so in the morning to get yourself ready, just like everybody does. Clean up. Go to the bathroom, which is a little intricate in space, make yourself some breakfast, read the day's plan. And then we have a meeting with all of the mission controls all around the world where we talk to each of them. There's one in Europe, there's one in Montreal, there's one in Houston, Moscow, and Japan. And then once everyone's told us the important stuff for the day, then we work our way through experiments, fixing equipment, maintaining the vehicle, all the various things you might do. A couple breaks for meals. It's evening time. Oh, during the day we exercise 2 hours as well, because without fighting gravity, you could be really lazy. So even my microphone floats, as you say. So so we exercise 2 hours a day, have dinner, and then you have about an hour and a half in the evening to try and catch up on personal things. Maybe look out the window, take some pictures, play a little guitar, talk to family, and then go to bed, get 6 or 7 hours sleep, and repeat. And we pretty much do that every day for the whole 6 months we're here.
And Commander, how are you feeling now that you've been up there as long as you have already, and you've got, you know, the rest of your time there for your 6 month tour? How do you physically feel now?
I completely feel adapted. I feel like a spaceling. It sounds weird. It's not a very common word, but I don't feel like an earthling. I mean, I can fly and float and turn upside down. I don't need to touch the floor. It's a whole new way to be, and at first it feels very strange, but now you don't even think about it. You're just, if you want to put something somewhere, you just let go of it, and you become graceful and elegant in weightlessness, maybe like a porpoise in the water, or a swallow in the air. And at first you're clumsy, you bump into things, but after a while it really feels natural. In fact, it's a big improvement on gravity. Nothing sags on your body, so it's gratifying when you're in your 50s, and it's a wonderful way to be able to fly and float and take advantage of this really rare experience. And that's just the physical side of things.
There's so many interesting things that you've been sharing with us, not the least of which we saw you making a peanut butter sandwich. Tell me about some of the, not the dangers, but some of the troubles or some of the things you have to be careful about with regard to eating.
You know, try eating a lunch sometime where you lie on your back and you make your whole lunch holding the food up in front of you, above you. You know, opening up a can, opening up anything, trying to use utensils where you can't set anything down, and everything that you open, there's nothing to keep it in the container. That's sort of what it's like. I just brought a can of typical food that we eat here. This is a white bean puree, and it's you know, it's got a pull top, but of course if it's a liquid inside, as soon as you open this, you're going to have a big ball of white bean puree floating around. So hopefully the manufacturer has thought to make everything sticky in there. And your fork, if you turn around, your spoon is gone. We can't really heat our food very well. Everything just comes like this, pre-made and pre-packaged. So we just have sort of a little, you know, easy bake oven that we warm things up in. There's no real chiller for the water. So the food isn't really cold, and you can't make anything fresh, of course, because it's like being on a long voyage anywhere, a long sailing voyage where everything has to have a long shelf life. But we have dietitians and health specialists on Earth in Montreal with the Canadian Space Agency and at NASA and in Russia, and they really take good care of us. There's a big variety of food. It tastes good, and it's keeping us healthy. So even though it's a little tricky eating up here, as you saw in the peanut butter video, it's quite pleasant. It's something we look forward to, both just for the food, but also as a social get-together.
There's so much that is so fascinating about this mission, and you've been able to share all of it with us through social media, through taking pictures. Just yesterday, we saw a picture that you took of Mount Etna. Some of these images are just stunning. I don't know how you have time to do it, but you do it. You've got so many followers. Tell me, when you first saw this picture of Etna and you took it, what you thought.
Well, I get tremendous support from the ground. The Canadian Space Agency has a team of people that have been working on this flight for a couple of years, and they're doing a great job. My children as well, especially my son Evan, has been helping me, an old guy like me, understand social media. And with that whole team, we've really had a chance to include a lot of people in this. And so they send me information. I got a note saying that Mount Etna was erupting, and then the people at NASA also said, hey, here's a particular pass where the lighting might be good. And so I set the alarm on my watch here and went over to the window at the right time and grabbed the camera and tried to take some pictures. And it's, Beverly, it's sort of like almost a miracle when you're working away in what looks sort of like a building, and you float over to the window, like that one there, and you look outside, and you're transported. You're suddenly, there's the whole world in all of its curvature in front of you, and there's a volcano out of the world that is spewing ash and smoke and steam, and you float the big lens up in front of you and zoom in on it, and you can see how the energy from that volcano, from this great big Earth that we live on, is spewing the energy of the Earth up into the high atmosphere where it's being picked up by the jet stream and carried out over the Mediterranean. And we're going 8 kilometers a second. So we come up, you start getting your camera ready over Africa, and you come across the horizon, and there's Mount Etna, and you take pictures as it rolls by in front of you, and then the next thing you know, you're over the Black Sea and up and over Kazakhstan and gone. So it's phenomenal. And as you say, I'm working all day on all the science we're doing here, but at the same time, the distraction of what's out these windows and the lure of the magnificence of our own planet is a magnet that constantly pulls you away.
And it's such a lure for everybody here on Earth, and we've been watching with interest. You've been speaking to so many students and classes. They ask you great questions. It must be wonderful for you to be able to share and see the excitement that these kids share in your mission.
Yeah, when I was a kid growing up, it was the very start of space exploration back in the 60s and early 70s. And I was fascinated by it. I thought of all the things that are going on with our species and our history right now. This is something really new in the human experience, to be leaving our planet. And so I was really excited about it as a kid. And whenever somebody's taught me, I've always sort of felt that, well, now I have an obligation to try and share the privilege of things that I've learned with other young people, same as people did with me when I was little. And so I really, over the last 20 years as an astronaut, have spoken right across Canada and up in the Arctic, and trying to let people know the opportunities that are there. This is something that Canadians do. There's Canadian hardware on here. The Canadarm built this place. It's just on the outside. There's a Canadian science experiment looking at how tiny nanoparticles react, doing fundamental research right over here behind me. And all of this is going on. It's an opportunity for Canadians, Canadian universities, Canadian businesses. And so I'm the lucky guy who gets to be here. But I really consider it a vital part of my job, not to keep this experience to myself, but to use every means that I can think of to try and share it, to try and let people see what we're doing up here and the fact that we are starting to leave our planet permanently for the first time in history. It's a pretty interesting stage, and now with the technology that's available, to be able to immediately share a picture of Mount Etna or some random thought or some emotion that's going through, it really even makes it more accessible, and for me, more rewarding to be able to not just keep it to myself, but to be able to let people right across Canada share it.
And I guess we can add Canadian music to that because of your song and the Bare Naked Ladies, and the fact that students are going to be singing this song, your song, on Music Monday. What do you think of that?
I think it's tremendous. I went through the, of course, the Canadian school system. I had music teachers in elementary school and high school. Miss Soren, who taught me in high school, taught me how to read music and how to play musical instruments. And when we looked at this Coalition for Music Education right across Canada, they have a great program with Canadian schools, and we thought, why not participate in that? Invited Ed Robertson, who I'd known for years. The two of us wrote a song together, joined with the choir, the Gleeks from Wexford, and sang this song. And it really came off nicely. It's a song about exploration, about starting to leave the earth, about putting all that into personal perspective and what it means to us. And Ed and I really liked the song that we wrote, and it's going to be sung by schools. I mean, I invite all Canadians to listen to this song. You can see it through the Canadian Space Agency website and through Music Mondays and Coalition for Music Education. And it's going to be in schools across Canada on the first Monday in May, Music Mondays. I think it's the 6th of May. A song called Somebody Singing, ISS, International Space Station. And for me, music is fundamental to humanity. They've found musical instruments when we lived in caves 40,000 years ago. Of the few artifacts, the things that people made, they made musical instruments back then, before written history. It's an ancient necessity for humanity. And to be able to have a guitar up here, to be able to write and play music up here, to be able to then share it and have Canadians join in voice and song, is just another wonderful way to try and help communicate not just the science, which is important, but also the art and the humanity of this experience. And I really hope lots of Canadians will have a chance to join in the music. Why not?
It's really great to see you holding that guitar. And with the weightlessness, when you play that guitar, does that feel different?
Oh, it sure does. It's the guitar, just kind of like this microphone. The guitar just floats in front of you, so you don't need a strap. But it is a little weird to fret up the neck because your arm doesn't weigh anything. So you kind of have to pay a little more attention when you're playing up and down the neck. You need to really think about where your hand's going. But fortunately, there's a Canadian guitar on board made out in Vancouver, and that was just a lucky coincidence to have a Canadian on board with a Canadian guitar. And in my spare time, I've been playing lots of Canadian folk songs, Stan Rogers and Gordon Lightfoot and M. Greiner and a bunch of music, and having a chance to play some songs that I've been writing and record music. It's just, it's not the main purpose of what we're here for, but having that as something to do in my spare time is something I do on Earth, and it's a wonderful facet of of actually living in space.
Yeah, I just love it. And, given the amount of space that you have for personal life, what other kinds of personal things did you bring with you? I mean, obviously you've got a guitar. What other kinds of things were important to you to have with you?
Well, I looked at this, of course, as sort of a very significant event within my life, within my family, my extended family's life. And so I invited, of course, each of my family members, brothers, sisters, children, my wife and parents, of course, and asked them if they would like me to bring something up for them. And we're very, very space limited. I came up and I helped. In fact, I was like the pilot of the Soyuz, the Russian rocket ship, spaceship that we flew up here. So in fact, everything I could bring had to fit in a package about as big as one of those little loaves of bread, and couldn't weigh more than 1.5 kilos. So just small things. But almost everybody has some small little, maybe something that's historic to them or personal to them or important. And so I collected those from all my family, little, jewelry or maybe something from a grandparent, something that's been passed down through the generations, little things like that. My brother wrote a song, that I brought up the sheet music for, that type of stuff. And now I have that up here. And it's really nice actually to go through them one by one. Of course, I want to photograph with them, but to take them out and think about this is the embodiment of a friend or a history or a whole story, each one of them. And to float it weightless next to myself, snap the camera with the world in the background, not just knowing that this is an interesting photograph, but this is an encapsulation of humanity in time, looking at it, putting it back in the package and taking on another one. It's a personal but a really touching moment for me, and a real joining moment with everybody that's important to me.
Wow, and you know, you're so busy up there with the experiments that you've mentioned, and such a full day. You are about to take over command of the International Space Station. Are you still going to have time to do your tweets and your photographs and all of that we love?
You just can't deny it. And I mean, I could sleep longer, I guess, but that would be a waste. I mean, we have a very regimented life. We, in fact, have a schedule on a computer that moves in 1 minute increment. Our life is scheduled to 5 minute increments for the whole 5 months. But there's a little bit of gray space at the start of the day and the end of the day. And there's also a block where you're supposed to be asleep. And yes, I do. I take over to command what is, in effect, the world spaceship here in a couple weeks, which is just amazing for me to even contemplate that. I can accept the reality of it, but in my heart, it just still is kind of daunting and surreal. But I definitely need to address that role. Of course, my regular working day here, but at the same time, I'm not going to spend my evenings and spare time, you know, watching movies or not being productive. That's not what people put me here for. It's definitely not what I want to do, and I'm in such a rare position on behalf of so many Canadians, so many of my co-workers, so many people, that I want to live this experience just as fully as I can, share it with Earth real time, but also absorb it as completely as I can so that I can reflect it back and reflect on it and let people know what it means to all of us, you know, for the rest of my life. So yeah, I'll be busy, but this is a good place to be busy.
I know there's going to be a lot of things you're going to want to do, not the least of which is hug your family when you get back, but what would you look forward to being able to do once you're back on Earth?
It's a very quiet, austere environment here. Great people, super competent, undemanding, self-starting group of 6 humans that I'm up here with from all around the world. It's interesting, we grew up speaking different languages, very different cultures, people from Belarus and Russia and different places in the United States, and me from Canada. And yet, this little microcosm, we have a wonderful time working here, but it's also, you know, somewhat monastic, and I'm very much looking forward just to the contact of being back on Earth, the noise and the tumult and the wind in your face, and being able to give someone a hug and just the regular messiness of life. I'm looking forward to that. I'm looking forward to, of course, we have all the compulsory things, but to relaxing, to getting back to our cottage in Canada and spending the time with my feet up, trying to put all this together and figure out, you know, what it really means, and somehow fit it into the rest of my life, and try and really put it into context of everything else that's going on. So I think the debriefs, the rush of humanity, and then a chance to really reflect on it. There's all the trivial stuff of, you know, food that I want to eat or something, but in truth, it's the opportunity to really make the most of it that I'm looking forward to when the pace slows again.
Commander Hadfield, this has been such an incredible opportunity to speak with you. You've been such an inspiration, continue to be. Best of luck and safe travels for the rest of your mission. Thank you.
Thank you very much. It's been a real pleasure to talk with you. Thanks for having me on. Bye.
The station, this is Houston ACR. That concludes the event. Thank you.
Thank you, CTV Studios. Station, we are now resuming operational audio communications.
This is Mission Control, Houston. Thursday was a light duty day for half of the International Space Station's Expedition 34 crew members to make sure that they are rested and ready to work this weekend with a new shipment of supplies arriving on board a commercial cargo ship. Station Commander Kevin Ford and flight engineers Chris Hadfield and Tom Marshburn had their regular exercise sessions today, but little else on their schedules in advance of the targeted Saturday arrival of the Dragon cargo ship. The second operational flight of the vehicle from SpaceX remains on target to launch from Cape Canaveral Air Force Station on Friday morning at 9:10 Houston time. It'll be carrying 1,200 pounds of science experiment materials and crew supplies. Plans call for it to arrive at the station on Saturday morning, when it will be grappled by the crew, who will be at the command of Canadarm2. And then they will berth that cargo ship to the Harmony module, to its port that faces down toward Earth. The schedule calls for the hatch to that new cargo ship to be opened on Sunday for the crew members to start unloading. Chris Hadfield did have some work today. Before his interview event with the Canadian television network CTV's Canada AM program in Toronto, Hadfield completed pre-packing of items that are going to return to Earth on Dragon. The plans call for 2,300 pounds of equipment and experiment samples to be brought back to Earth March 25th, when the Dragon's spacecraft splashes down in the Pacific Ocean. Today, Tom Marshburn set up a high-definition television camera in the Destiny laboratory so that it can send images of the robotic workstation monitors to the mission control centers so that the ground can see what the arm operators will be seeing while they're at work. The arm operators, Ford and Hadfield and Marshburn, will actually be working from the robotics workstation in the cupola module. The camera that Marshburn is setting up today will be shooting the monitors on the backup robotic workstation, which is located in the Destiny laboratory. Marshburn and Ford each also took time on Thursday to use the station's amateur radio to talk with school students on the ground. For Ford, so the students were in Avon, Connecticut. For Marshburn, the students are on the ground in a suburb of Athens, Greece. Thursday, a regular workday for the Russian segment crew members. Flight engineers Oleg Novitsky and Yevgeny Tarelkin spent half their day laying cables in the Russian segment to support a plasma wave experiment that is going to measure the electromagnetic field around the outside of the space station. The exterior hardware for that is going to be installed during a spacewalk that is planned for April and will be conducted by flight engineer Roman Romanenko and Pavel Vinogradov. Vinogradov is due to arrive at the station in late March, along with flight engineers Alexander Mazurkin and NASA astronaut Chris Cassidy. Roman Romanenko occupied most of his morning on Thursday taking surface samples in the Russian segment and then science experiment operations in the afternoon. Novitsky was busy stowing items destined for disposal into one of the Progress ships that's docked to the Russian segment, and Tarelkin did maintenance work and shot scenes for a Russian television documentary about the station's payload operations. On Friday, the 3 U.S. segment crew members have some final training for their robotics operation for the grapple and berthing of the Dragon spacecraft, and then they will be off duty for most of the day on Friday, with the intent that they will be well rested and primed for action on Saturday to greet the Dragon cargo ship that is bringing more than half a ton of materials to support the ongoing mission of the International Space Station.
NASA is the 9th largest federal government real property holder, with over 124,000 acres and 4,900 buildings and other structures. Agency property includes technical facilities such as wind tunnels, rocket test stands, and launch complexes, and non-technical facilities such as office buildings, roads, and utility systems. Much of NASA's infrastructure was constructed in the 1960s during the Apollo era, and nearly 80% of its facilities are 40 or more years old. Although NASA has identified reducing its infrastructure as high priority for decades, the agency continues to retain property that is underutilized, does not have identified future mission uses, or is duplicative of other assets in its inventory. In this audit, the Office of Inspector General identified 33 wind tunnels, test stands, thermal vacuum chambers, airfields, and launch-related facilities that NASA was not fully utilizing, or for which agency managers could not identify a future mission use. These facilities cost the agency more than $43 million to maintain in fiscal year 2011 alone. The OIG found that NASA's efforts to reduce underutilized facilities have been hindered by several long-standing and interrelated challenges. 1, fluctuating and uncertain strategic requirements. 2, agency culture and business practices. 3, political pressure. And 4, inadequate funding. To its credit, NASA is undertaking a series of initiatives the OIG views as positive steps toward right-sizing the agency's real property footprint. Development of a new facility strategy and analytical framework for making infrastructure decisions, as well as improvements in managing its real property data, should position the agency to better manage underutilized property and divest itself of facilities that are duplicative or unneeded. However, many of these efforts are in the early stages, and their ultimate effect on the agency's ability to reduce its real property portfolio remains unclear. In addition, we noted that the agency's efforts may be insufficient to overcome the cultural and political obstacles that have impeded past efforts to reduce unneeded infrastructure, and that accordingly, an independent outside process similar to the Department of Defense's Base Realignment and Closure Commission may ultimately be necessary. To read the OIG's full report, please visit our website at oig.nasa.gov.
Hello, and welcome to this NASA briefing about an exciting new discovery scientists have made around Earth's radiation belts. I'm Steve Cole from NASA Headquarters Office of Communications. We're bringing you this briefing today from the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland. Our panel today is going to talk to you about a new finding that's just been released today that is using data from NASA's Van Allen probes mission, which was just launched last year. Our panel today, we have 4 panelists. Let me introduce you to them. First is Mona Kessel, Van Allen Probes Program Scientist from NASA Headquarters in Washington. Dan Baker, Director of the Laboratory for Atmospheric and Space Physics at the University of Colorado in Boulder. Nikki Fox, Van Allen Probes Deputy Project Scientist from the Johns Hopkins University Applied Physics Laboratory, and Joe Kunches, space scientist at NOAA's Space Weather Prediction Center in Boulder, Colorado. After our 4 panelists have given opening remarks, we'll open it up to questions here in the audience, people watching on NASA television, and media on the phone lines. If you're watching on NASA TV, you can ask a question through Twitter by using the hashtag AskNASA. Okay, we'll begin with Mona.
Thank you, Steve. So NASA's radiation belt storm probes launched last year, as Steve said, in August 2012. And right away we went into a 2-month time period of we call commissioning, where the doors open, the booms deploy, the instruments turn on, and we start ramping up the high voltage. What we're trying to do is check out all the instruments, make sure everything's operational. So that was 2 months. As soon as that period was over, then NASA renamed the mission the Van Allen probes. That was in honor of James Van Allen, who launched the Explorer-1 satellite in 1958 that discovered the radiation belts. So if we go to the first graphic, thank you, that shows the famous picture of Pickering, Van Allen, and von Braun holding up the Explorer-1 satellite right after their successful launch. And on the right side is a picture of James Van Allen from Time magazine, and that was because after that mission went and the subsequent missions, he and his team pieced together the information that let us know, or that deduced that there was trapped radiation in the Earth's magnetic field. And so that trapped radiation is now called the Van Allen belts, and so this mission is named in honor of him. But what are they? What are these radiation belts and where are they? If we go the next, thank you, then you can see this is a schematic. You see Earth in the center, you see the sun off to your left, and you see two red regions. This is a cutaway view, so these are donut-shaped regions that wrap around the Earth. There's an inner belt and there's an outer belt, at least as far as we have understood from the beginning of the explorers. So what happens is there's trapped radiation in those two areas. The inner belt runs from about 1,000 to 8,000 miles above the surface of the Earth, and the outer belt is from about 25,000 to about 12,000 to about 25,000. So these satellites travel through these belts all of the time, and you can see some of them pictured up there. You can see the two Van Allen probes. You can see GPS. GPS travels through those regions all the time, even in quiet solar conditions. But when we have disturbed conditions, when there are solar storms, then the belts expand. The inner belt will actually come down into the region where the International Space Station flies and other low-orbiting satellites. And the outer belt expands outward. And so it encompasses the area that we call geosynchronous orbit, where a lot of our communication satellites are. And there's about 300 satellites out there. So these satellites then are in the way of potentially harmful radiation. It can affect their electronics, and it can pose a threat to astronauts and all of our satellites that are there. So the radiation belt storm probes, now the Van Allen probes, was the second mission with the Living with the Star program. Pictured here, this is just a couple of images to give the sense of what the Living with the Star program is about. It's making the connections between the assets from the sun to the Earth that affect life and society. So you can see there astronauts, you can see greenery for plants, you can see there are fisheries there are power systems. All of these things are affected by space weather, as we call it, affected by these radiation belts. So Joe Kunches later in this presentation is going to talk about that a little bit more. And the only thing I still want to tell you now is about the Solar Dynamics Observatory, which was the first mission with the Living with the Star program. I'm going to show you a video. This is right after launch, where a filament from the sun erupts from the atmosphere of the sun out into space. It carries with it, it's a coronal mass ejection that's actually headed towards the Earth. And you can see another picture of it here with SOHO, which is one of our older satellite assets. And this will come back to SDO and show you that again, this filament that bursts out into space. So those happen all the time on the sun, but they're not always directed at Earth. This one was, at least as a glancing blow, and it came to the Earth, and our radiation belts exploded with things that were happening. And so now I'm going to turn this over to Dan Baker and let him tell you about this remarkable discovery.
Thank you, Mona. Yes, I'm going to talk to you today about the science paper that's being published today in the journal Science, actually online, Science Express. I'm going to talk to you about the confinement of these very high-energy particles in Earth's magnetic field. As Mona noted, for the last 5 decades, we've been told in the textbooks that the Van Allen belts consist of 2 regions of trapped radiation, the inner stable zone, a slot region, and an outer zone. What we found rather remarkable is just a couple of days after turning on our high-energy electron detection instrumentation, that we really saw that there was a 3-belt structure. And this persisted for 4 weeks and then really turned off. If I could have the first graphic, please. This is several different energy channels displayed across in time. The vertical axis is essentially distance measured out from the Earth in Earth radii. And if you do the next graphic click here, you'll see that we saw the inner belt, we saw the expected slot region, and then we saw this new emergence of a 3rd belt and a second gap region, a second slot. If we go on to the next slide, or the next animation really, I'd just like to tell you that the relativistic electron-proton telescope was put onto the spacecraft. You see the integration process here. It was really geared toward measuring the highest energy particles confined in the Earth's magnetic field. And what our goal was to really be able to measure to higher energies with better energy resolution, better temporal resolution, better spatial resolution in order to address these very long-standing questions about how particles are accelerated and lost from the Van Allen belts. If we could have the next graphic, please. Further motivation for us was the long run of data that we had from another NASA mission called the Solar Anomalous Magnetospheric Particle Explorer, SAMPEX. This was launched in 1992. It made measurements in low Earth orbit. It was really not operating in the throat of the cosmic accelerator that operates in our neighborhood. But it was really revealing the inner belt, the outer belt, the slot region over a long period of time. We learned early in the summer of 2012 that the SAMPEX mission was going to come to an end. Atmospheric drag was going to bring the spacecraft down and cause its demise sometime in the fall of 2012. And so we went on a campaign to try to turn on our instrument, the REPT instrument, as early as we possibly could after launch. In the normal flow of commissioning that Mona talked about, we would have turned on about 34 days after launch. We really were able to turn on 2 days after launch. And we were very fortunate that we did, because if we go to the next slide, what we saw when we first turned on was that the belt had the two-belt structure as we expected, and then as time marched on, we saw this emergence of three belts. And the lower panel really shows here the kind of collapse of all the orbits onto a single meridional plane. And as you watch this, you can see that this third belt emerges pretty clearly, and then like a knife edge, the entire outer Van Allen belt is ripped away. And then there's a new emergence of this, and I'll just ask that we go through this again so you can see that sequence again. Here we are seeing the single storage ring feature, as we call it, and then we see the entire outer belt outside that storage ring undergoing all kinds of dynamics. But this storage ring, or torus, is just there very persistently and unchanging for the better part of 4 weeks. We first foolishly thought the instruments were not working correctly, but we quickly realized that that couldn't be true. It had to be a real phenomenon. We've been studying that now. If I could have the next slide, I'd just like to show you then an animation that's been put together by scientists here at the Applied Physics Laboratory, in which we've assimilated the data into the models and are now portraying this the way the kind of global radiation belts work. And so what you can see, the sort of on either side there, you see this bright, stable kind of band outside the slot region, and that's the storage ring. The entire further outer part of this is undergoing all kinds of dynamics, but that feature is just there, rock solid, for 4 weeks. Very puzzling, very exciting, and as I say, the chance to really rewrite some of the understanding that we thought we had for the past 50 years. So I'll turn it over now to Nikki Fox.
Thank you, Dan. So Dan has presented some really fantastic results, new, exciting results today. And it really goes to show that even after 55 years after the discovery of the Van Allen belts, they are still surprising us. We really thought we knew them, but clearly we didn't. We've always known, as Mona said, that there were two distinct belts. We did know that the outer one was very dynamic and responded to these large events coming from the sun, but we had no idea of the structure that was embedded within that outer belt. So it really is a case of the observations leading theory, and certainly the theorists and the radiation belt modelers are scrambling to catch up with these great observations. One of the reasons that I think that there are so many mysteries still in the radiation belts is because they are home to a host of fundamental physics processes that are occurring throughout our universe. The same physics that causes the particles to be accelerated in the Earth's radiation belts also causes radiation belts to occur at all of the large magnetized planets in our solar system. So Neptune, Jupiter, Saturn, Uranus all have radiation belt structures very similar to the Earth. Even outside our solar system, particle acceleration is also causing distant nebula to glow in X-rays. So, as we say, it's just rocket science. It's just particle acceleration. It's the same thing that's happening here is happening everywhere. And we're very lucky that we have this region of interest just a few thousand kilometers above our head. It's really rather like having your very own particle accelerator in the backyard. What also, for me, makes this event even more interesting is, as Mona spoke of initially, the sun drove that large storm that actually caused the beautiful event to be kicked off. And as we show here, SDO also caught the event that actually caused the annihilation of the radiation belt. So that knife edge that Dan showed, where you see the outer belt almost disappearing, was also driven by our star, the sun, always the star of the show. So the sun giveth and the sun taketh away. And one of the central themes of the radiation belt storm probes mission is to really see why the radiation belts respond in such different ways to seemingly similar events coming from the sun. And the only way that we can really do that is to really take a system approach and look at everything coming from the sun to our Earth space. And so this animation shows nicely how the radiation belt storm probes, or the Van Allen probes, have now taken their place in the Heliophysics Observatory. So you're seeing a fleet of spacecraft in all the key locations between the sun and all the way to Earth. What makes the radiation belt storm probes so important is that they really have taken their place here. They are designed and developed to go after the physics that is occurring in the radiation belts. So they will really be providing those much needed observations so we can decide what's really happening in the radiation belts. Also on board the spacecraft, we have a full complement of instruments. So in addition to the highest quality particle measurements that have ever been made that Dan has already showed, we also have fields and waves instruments. So we're now going to study all of the wave structures that are maybe responsible for causing that third belt and eroding that center part in the outer radiation belt, which we've termed the second slot region. So we're very, looking forward to these great new capabilities we have, not only providing discoveries, but also providing explanation as to why these phenomena are occurring. And also, as Mona said, the practical nature of the effects here at Earth, they are causing dramatic changes in our near-Earth space, which have effects on life and society. We live and work in the radiation belts, and all our technology is based there. So understanding how the radiation belts change is extremely critical for our technological infrastructure. So in addition to the wonderful science that we have with the storm probes, we're also sending down real-time data, real-time space weather data that comes down and is captured through a network of ground stations and then is available within about 30 minutes on the web. And obviously scientists are very excited about these raw data, but we understand that they're not always accessible to the general public. So we actually feed them into models. One really good example is the DREAM model, which is run out of Los Alamos National Laboratory. And we are in the process now of feeding our real-time data into this model, and within the next 3 months we will be delivering that to the NOAA Space Weather Prediction Center, where they'll be using it to better forecast space weather. And that's a good segue to pass on to Joe Kunches from the Space Weather Prediction Center to tell us all about space weather.
Thank you, Nikki. Discoveries from missions such as the Van Allen probes are really the wellspring from which improvements to operational space weather services come. And let me take you into the forecast office of the Space Weather Prediction Center here in a minute and show you what it's like to do operational space weather forecasting. This is the forecast office from NOAA Space Weather Prediction Center. We operate 24 hours a day, 7 days a week. We monitor space weather and we make the predictions that people want to plan from. We coordinate our activities with the U.S. Air Force. They have their own center at Offutt Air Force Base. And we're the World Warning Agency for 14 countries. The International Space Environment Service is focused at Boulder. Among the data that are used there, along with the GOES data from NOAA, also you'll see NASA data from SDO, from ACE, from Stereo, from SOHO, and also those data feed into models. Here is the Enlil model from the solar wind that we get, and it enables the forecasters to make the best assessment of the current conditions and allows them to give good predictions of the conditions in the near future. In the next slide, I'll show you how one of the ways in which we get the word out from in real time as conditions occur. This is a graph showing in white the progress of the current solar cycle, and in blue the number of subscribers to our email product subscription service. Now it numbers more than 32,000 subscribers. Of those subscribers, about 9,500 characterize themselves as having something to do with satellites. Either they are designers, they're engineers, they're manufacturers, they're operators. So clearly the satellite community is a very important community for us to serve with the best real-time space weather information that we can garner. Now, to focus for a minute on the satellite community, this probably comes as no surprise to anyone, but in the next slide, here's a chart from the Satellite Industry Association which shows the revenues over about the last 5 years. This goes back to 2006. 2011 is the last full year for which the data are available. And what you can see without looking too hard is that its growth, 9% about on average over the last 5 years. But also the last year is about $177 billion worth of revenues, further underscoring the fact that this is a very important customer base that needs the best space weather information they can get. And finally, just to maybe wrap it up, what is it about the space environment and space weather that causes disruptions to satellites? And this really goes to the activities that the Van Allen probes are designed to do. It's charged particles. And on the next slide, there's an illustration of the kinds of things that can happen to satellites by virtue of, say, low-energy electrons, which can do surface charging, or high-energy electrons, which can embed themselves within the spacecraft and cause deep dielectric charging. Or it can be protons or galactic cosmic rays that cause single-event upsets, and en masse, the lot of them, cause radiation damage to the solar panels and other systems. So it's very, very important for the satellite community to have the best, the most timely information that they can get, and that's the purpose of this activity, and I'm very happy to be here to participate in this. So I'll turn it back over to Dan for some concluding remarks.
Thank you very much, Joe. It's a delight to be able to tell you that we turned on our instruments and we saw fascinating new phenomena in the Earth's vicinity driven by solar disturbances. It's also a delight to be able to tell you that we are really able to do so much research with our basic research, astrophysical research, if you would say, in our local neighborhood. But it's wonderful to be part of a field where that research also has good practical applicability. And we know that the things that we're measuring now have the kind of relevance to society that Joe's spoken about. So we're delighted to try to answer any questions you may have today and to talk about this duality in our field, great basic research and also great applicability to societal needs. Thank you very much.
Okay, thank you, Dan, and thank you to all the panelists. We'll take questions now from media in the audience, on the phone lines, and then also from you all watching online. As a reminder, you can ask a question via Twitter by just using this hashtag, AskNASA. If you have a question in the audience, please get to one of the people with the microphones over here. We did receive a question or two before the briefing, so let me just throw that out to begin with. First question, what has this third Van Allen belt been doing since you first observed it last year?
Well, I can try to answer that question a bit. We saw this phenomenon for about 4 weeks. Then, as the data showed, and as Nikki remarked on as well, it was cut off like a knife edge. It disappeared. There was a rebuilding of the Van Allen belts also in a very abrupt fashion on about the 9th or 10th of October. But since that time, we have not seen a recurrence of the third belt. We're watching with eagle eyes to see if there is a resurgence of this. But so far in the last 5 months, there really hasn't been a recurrence of that.
Okay, and I guess we have some questions already via Twitter.
Yes, I read that CRES saw a third ring in 1990 and solar activity in 1998 made a brief third ring. Is this really the first time we've seen a third ring?
The CRESS was the mission that was mentioned back in 1991, and that showed a new population of particles injected into much deeper into the magnetosphere, into more or less the inner zone and slot region. This is the first time that reported in the literature that one has really seen embedded in this outer part of the Van Allen zone the storage kind of phenomenon. And so we believe that this is a fundamentally different than what's been reported in previous kind of observations back in the past.
Okay, is another question from Twitter?
Yes. Which belt was actually new? Was the original outer belt, did it shrink back into a storage ring and then a new belt form outside of that?
Well, let me again try. We're still trying to piece together exactly what happened, but yes, it seems as though an entire outer Van Allen belt acceleration event occurred, and then part of it was sort of ripped away, was torn away from the outermost part, leaving the storage ring, and that's what persisted so immune apparently to external forcing for the next 4 weeks. And so what we were really seeing was that the storage ring was the remnant of an earlier acceleration event due to the kind of solar drivers that Mona and Nikki talked about.
Let me add to that also, if I may. This is still early days, and so we don't completely understand this phenomena that we're seeing. We're modeling it now. We're trying to develop the understanding. We're looking, as Nikki mentioned earlier, at the wave instruments, because they are likely one of the drivers, the waves that are generated. And it's all driven by the sun, but then there are internal waves that are generated as well. We're trying to piece this all together right now, and stay tuned. We will know more.
That's really what's exciting about new observations, is that when you know you've done something right observationally, when theoreticians say, well, that doesn't look right, we've got to go back to the drawing board here.
Okay, and one other question from Twitter before we go to the media.
A two-pronged question. What does the third ring mean for astronauts and satellites, and also what impact will it have, if any, on the Earth?
Well, we might let Joe take part of that question. Joe?
Yeah, I think it probably will have little impact on astronauts and satellites, given the characteristics. But I would hurry up to say that there's still a lot that we don't know, and we can talk about space operations of today, but also there's operations in the future that are planned. So I think probably the true answer to the question is still to be known.
And if you remember the picture that I showed during my presentation, the International Space Station is down below the inner belt. This new ring is actually much further out than that. It's at about 12,000 miles above the surface, so it's much higher than astronauts go. Now, if we send another mission to the moon or to Mars, then we would have to pass through the region. But we've done that before, too, in the past with Apollo. We passed through pretty quickly. So, but in realistic terms, it's not going to affect our astronauts, certainly not on the space station.
Okay, another.
But having said that, the regions that we're looking at with the third belt are magnetically connected to the altitudes that the space station is orbiting on. So while there's no direct impact, there are still going to be effects that are seen, and I think that just understanding more about the outer radiation belt, its structure and its dynamics, are very important for enabling us to have better models, better prediction models, do a better job of predicting the lifetime of spacecraft, just by knowing that it's way more dynamic than we had even expected prior to the launch.
I'd like to jump in on this and just say, too, that we're fortunate that nature performed an active experiment for us that really gave us this very kind of discrete onset and then a very discrete end to this particular three-belt phenomenon. And this is going to teach us a lot about how effectively the magnetosphere can store and maintain an electron population for extended periods of time. And by doing that, I think it's going to greatly help us greatly increase our understanding of just how this complex accelerator that Nikki talked about really operates.
Okay, our next question.
Do you have an estimate of how the total energy content of the three, then two belts changed during the process?
Let me first say that I want to emphasize what Mona said too, which is that we're just studying these things now. Many of the questions that are being asked are exactly in our minds, and we're going to try to more quantitatively address those. So this is relatively early in the mission. We're trying to piece together what happened, why did it happen, and what are the implications for such things as total energy content.
Okay, our next question, still from Twitter.
How did this radiation belt go undetected for so long?
We've never had the capability and the outstanding technology that we have with the radiation belt storm probes, the Van Allen probes, I'm sorry. You know, it is a mission that is designed to go after the dynamics and the structure of the radiation belts. We're carrying the right instruments and we're in the right orbit to be able to do that. And I think the fact that we've had such an amazing discovery within days of turning on the instruments is really proving just how spectacular the science from the Van Allen probes will be.
I like to quote America's most notable philosopher, Yogi Berra, who said you can observe a lot just by looking. And I believe that when you open new eyes on the universe, you invariably see new things. And so I think that's where we find ourselves now.
Okay, our next question, please.
Question for Joe Conscious. What can operators and companies do in order to protect their satellites once they have the predictions?
Well, that's a good question, because it depends a lot on the particulars of the mission and what they're trying to do. But I can give you an example from the past. In 2006, the EUMETSAT, the European Meteorological Satellite Organization, launched a satellite called METOP. And METOP had on board 2 high-rate transmitters to send down broadcast direct TV-like imagery of the weather, and they really wanted to do it over Northern Europe. Shortly after the launch, they found that one of their transmitters quickly failed. Unfortunately, they had a backup on board, but before they turned the backup on, they wanted to figure out what the problem was in terms of the environment or exactly what. So they went back to the engineering lab and they found out that this particular piece of equipment had a susceptibility to charged particles that had a prevalence in the auroral zone and in the South Atlantic anomaly. So when they turned the backup transmitter on, they then organized or created a procedure through which they turn it off as it flies through the auroral zones, and they also turn it off when it flies through the South Atlantic anomaly, but then they turn it on the rest of the time. And in particular, they're able to capture the weather imagery from Europe, which at times is right on the edge between the auroral zone and the safe places. So depending on the kinds of activities and the particulars of the spacecraft, there are things that can be done to respond to the current state of the space weather. I don't want to say that every satellite works like this. There's a little bit of the 3 little pigs philosophy in building satellites. You can build your satellite out of bricks and you don't have to worry about anything. Well, that can be costly and heavy, and maybe you wouldn't be able to get the payload that you'd want at every point. So to then go to the less robust state, you may have to drive it a little bit, and many satellite operators will do that. They will reschedule command sequences. They will do the things that are at their disposal to account for harsh radiation conditions that can occur from time to time.
Okay, our next question, please.
Dr. Baker, could you briefly describe any innovations that improved the sensitivity and capability of the REPT device?
Yes, we tried to build with detectors that were more stable and more sensitive to charge deposition from the detected particles. We tried to build much faster electronics so we could avoid traditional problems of pileup and dead time and other such effects. But we really were primarily focused on being able to do a better job of resolving to a high precision the energy spectra at these higher energies. Many previous measurements have sort of just made very broad brush kind of measurements at the higher energies, and without the kind of energy resolution that we were able to achieve with the REPT instrument, I think we would have again probably sort of smooshed all this out, and we wouldn't have really seen so clearly at all that we had these kind of distinct spatial and temporal features.
Okay, next question, please.
Are the collapse of the outer belt and its re-energization connected with any external phenomena that you can identify?
Yes, I think all of us in a way have addressed that, but we see very clearly, and maybe more clearly than we ever imagined we could with the Living with a Star program. We're able to watch the ultimate driver, the sun. We can watch these things propagate through the interplanetary medium. We can then observe directly the effects with the radiation belt storm probes, the consequences in the radiation belt. So we're in an enviable time here where we can really watch cause and effect play out before our eyes. Maybe Mona or Nikki would like to comment.
We have seen in the past, when we've had coronal mass ejections, we have seen a drainage and then a repopulation of the belts. We've seen that before. That's pretty well established. What we haven't seen before is those from the original particles in the outer belt coming in and forming this storage ring or this extra area and then lasting for a month. That we've never seen before. But we pretty well understand, at least at some level, the process that happens to drain the belts originally and then refill them.
But the fact that very similar solar drivers can have such a different effect on the radiation belts is really the central focus of the Van Allen probes. Just, sometimes it does bring up the radiation belts and other times it just annihilates them, as you saw in the plots that Dan had. And I think that, now we've got the ability to really bring those outer belts into focus, as Dan said, with the new technology. What we saw before as kind of a fuzzy image, we're now seeing with great clarity.
I think since we're talking in fairy tales, the Three Little Pigs, well, we can also talk about Goldilocks and having the sort of the right intense enough, but not too intense, so you don't completely eradicate the outer Van Allen belt, but you eradicate a portion of it. I don't think we'd really suspected before that there could be this kind of Goldilocks event that would lead to this storage ring phenomenon.
Okay, next question.
Could the probes themselves affect the radiation belts, for instance, by generating waves?
No, the spacecraft themselves will not affect the radiation belts.
Only very locally, possibly. But
very
it's pretty unlikely that would have much effect.
Okay, next question.
Do any of the Van Allen belts intersect the Lagrangian points?
No.
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 Our simplest answer so far.
We all agreed.
We're all agreed.
Okay, I think that's all the questions we have online. Thank you for asking the questions. Thank you to our panelists. And you can follow along what's going on with the Van Allen probe mission online at www.nasa.gov/Van Allen probes. And you can keep up with all the different NASA scientific findings through our social media channels. We've got quite a wide array from them. There's always something amazing happening at NASA. Again, thanks everyone for watching. Have a good day.